the layout for you. Give me a
Sure.
second.
I've shared my screen. Yeah, it's visible, I think.
So I'm turning myself off here, and you
Okay.
can start your session. The stage is all yours, sir.
Sure. Thank you. Hi, everyone. I'm very excited to discuss with you how to set up a blockchain as well as how to secure it. I hope all of you have received the link for this presentation. The reason that I want you to download the presentation is because while we are discussing, there are going to be some links that you are going to click, which may not be possible if you're only looking at it on the screen. So the URL is with you. If you've downloaded it, great. What we're going to do is I'm going to begin with the tech terms around blockchain, then how to install a blockchain, some basic blockchain commands, and then we are going to discuss how to secure them as well as the security controls. Now, when we talk about blockchain security, there are actually 5 different elements that we need to consider. So, one is that there is a concept called immutability of data, which means you can prove in a court of law that the data has not been tampered. That is available to us because of the blockchain technology. But blockchain by itself doesn't really do all this, and that is the reason we use hash functions to ensure the integrity of the data. Then for confidentiality of the data, we use symmetric and asymmetric crypto. For ensuring the availability of data, we obviously set up a blockchain with multiple nodes so that even if some of the nodes are down, the others can continue to serve the data. And finally, for non-repudiation, we use digital signatures so that nobody can deny having signed a transaction or signed some data. Now, I'd be really happy if you keep this as an interactive session. So the moment you have a doubt, you can just type it into the chat and I'll immediately resolve it. So far, is it clear that because we are using these multiple technologies, let's first try to understand these technologies and what they really mean. Now, the first step is a hash function. Many of you may be aware of it, but let me just give you a quick overview. So a hash function is a mathematical algorithm which is going to give you a fixed length output. So let's say there is a particular hash algorithm called SHA1. No matter what input you give it, it will always give you a 40 character output. Similarly, SHA2, 3, and the size of the output increases. But what is very important to remember is for a given input, the output will always be the same. So for example, here, when I use the word Sanya in all small letters, it is going to give you this result, irrespective of whether you're running this hash function on, let's say, a Windows machine, Mac machine, none of it makes any difference. It is ultimately a mathematical formula. So for the small letter Sanya, it will always give you this. For the capital letter Sanya, it will give you this. And if you pick the first one capital, everything else small, it gives you something else, which basically means that if you change the input even by a single dot in, let's say, a 50,000 page document, the hash output will immediately change. And these are called one-way hash functions. So you can always take an input, feed it into the hash and get the output, but not the reverse. Just by looking at this output, you are not going to be able to find out what the input was. And this could be done not just for words, but you could take PDFs, Word documents, any kind of an input can actually be used. And in fact, in the blockchain world, transactions which we do, they ultimately also get hashed like this. Any questions so far? Oh. Now, the second point is, now if let's have a look at some of these hash functions or hash values. So if you just simply click on this, I think I'm going to share my screen. Okay. Yeah, I hope my screen is visible now. So here, I'm going to just enter any particular word. You can also try this later on your own. And now as you can see that the hashes for this word hello are obviously going to be different in every hash algorithm that we use. So if we use MD2, which is only 32 characters, this is what it will be. MD4, MD5, and all these are available. Usually in today's day and age, we use the SHA 512 or these are the commonly used options, but there are so many hash algorithms which can be used. By and large, the blockchains that we are going to talk about are going to be using the SHA family of hash functions. I hope that's clear so far. Let me just, yeah. Okay. Can you please tell me how we hack in blockchain system? Okay, it's a little too early to answer this question. There are actually multiple points through which you are going to be able to hack a blockchain. So I'm going to come back to that question a little later. Any other questions as of right now? Okay. Now we come to one of the most important concepts, which is what we call as the proof of work. In fact, this is the innovation that was done to make Bitcoin a reality. Now, proof of work was invented somewhere in the early 1990s, actually as a way of controlling spam email. But because Bitcoin's blockchain runs on proof of work, in fact, even Ethereum runs on that, it is very important for us to understand exactly how proof of work works. Now, to give you a simple example, I have created an input here. So let us say that we are sending an email to somebody. Now, in that email, we are now also going to send some code. Now, let's see how we are going to derive that code. So this first thing that you see, rn@asianlaws.org, is the sender's email address, separated by this small symbol here. Then we have the receiver's email address, which is rohas@primechain.in. After that, we have another symbol here, and then we have the date. So let's say this email was being sent on 11th of January 2021. Now, at the end of this, we have to generate this number, which you can see in red. That is what we call as a nonce, Nonce. Now, how are we going to generate it? So the sender, his computer system, is going to create this input and in the beginning write 0. Then run it through the hash function and get a result like this. But the rule here is that the hash must begin with 4 zeros. So the sender will keep calculating hashes till he hits upon a number where, for example, in this case, it is 44482. When that is used as a nonce and this entire line is hashed, the result begins with 4 zeros. So why do we call this as a proof of work? Because we recognize that we are going to work at calculating the nonce. So the sender's computer is doing some work, and that work is calculating hashes. And only when he finds a nonce where the hashes are beginning with 4 zeros, then he can send the email along with the nonce 44482. When the receiver's computer gets it, the email, they will again run it through the hash by using only one number, which is the 44482. If the resultant hash begins with those 4 zeros, they will accept it and say, yes, this email seems to have come from a genuine person. So as you can understand, the basic thing we are solving is that when a spammer sends out millions of emails, he is not doing any work, so he can send out a huge number of emails. But now if we force him to use proof of work, his rate of sending emails is going to slow down, because for every email he is going to calculate a nonce, and that takes some time to do. But the verification of the nonce is instantaneous, and that is the basic logic behind proof of work. Can you let me know if you have any questions on this? Is proof of work absolutely clear? It'd be great if you can just say even yes, it's clear, so that I know and I can immediately move on to the next one. I hope I'm audible and everyone's understood here. The reason I need to keep asking is because this is a digital session. I can't see faces yet. So is everything audible? Perfect. Great. Now let's move ahead. I have given you two links here. Later you can run them on your machine. And what I've done is I've actually given you a demo of how to run nonces and how a nonce solves the puzzle. If we have time, I will come back to this in the end. Otherwise, you can later try it on your own. Now, the next concept that we need to understand is called a Merkle tree. Now, let's say that we have 4 pieces of data. Now, this data can be a Word document, PDF document, a movie, or even a financial transaction. So we call it data 1, 2, 3, and 4. Now, each data can be hashed. We discussed hash functions. So we say data 1, this is the hash. Data 2, this is the hash. 3 and 4. Then what we do is we take the hashes of 1 and 2 and combine these 2 hashes or concatenate them to each other and rehash it, and then we get this. Similarly, for 3 and 4, we get this. Then we take these 2, concatenate, again run a hash. We continue to do this process till we are finally left with one single hash, which is this example here. That last final hash that we find is known as the Merkle root, and this entire chain of hashes that you saw is called the Merkle tree. So because of this Merkle root concept, even though we have like 10, 15,000 data points or transactions, Ultimately, we can calculate just one hash which represents all of them. And if you tweak or change even one of those hashes, or sorry, one of those data points, the final hash will not match. So if there are 10,000 transactions, I don't need to keep 10,000 hashes. I keep only one hash, and that one hash can tell me whether all those 10,000 transactions are correct or somebody has tampered with them. That concept is called a Merkle tree. Is that clear? Any questions? Again, somebody's going to have to say yes, no, or ask a question. Okay, great. Now let's move to the blockchain. What does a blockchain actually look like? Now this is very, very important for us to understand. Now every blockchain begins with block number 0, which is also called as the Genesis block. Now for sake of an example, let us first begin with block number 16. It is just a random thing. So let's say we are now, the blockchain has started working and we have reached block 16, 17, 18. Now let's take 17 as our core focus for right now. Now, what you see here on top is called the header of the blockchain. Primarily, it contains four things. Previous hash, that means hash of the previous block. Timestamp, which is the time of this particular block. Transaction root, which represents the Merkle root of all the transactions in this particular block. And finally, the nonce. That same example that we saw earlier in an email, imagine the same thing which is happening here in the block. So whatever block 16 header is, this data concatenated and hash becomes this. So that every block knows what is the hash of the previous block. So that if someone tampers with this guy can immediately identify something has gone wrong. Timestamp, of course, when this particular block gets hashed. Transaction root, Merkle root of all the transactions here. And nonce is that proof of work thing that we are going to calculate. Now, many of you may have heard that when we talk about Bitcoin, miners are solving a mathematical problem. Now, many times people don't understand what that means. This is the mathematical problem. They are trying to calculate a nonce. So basically, when you talk about mining machines, those are machines which are calculating a huge number of hashes every second. I'm going to show you what that looks like. And that is the mathematical puzzle that a miner needs to solve. And the first guy to do it is usually the person who gets paid the reward. So you must have heard in Bitcoin, for mining every block, initially you used to get 50 Bitcoins. Then it became 25, then 12 and a half. Now it's 6.25. So according to the initial Genesis block of Bitcoin, the first 4 years, for every block, 50 new Bitcoins were created. After that, for the next 4 years, 25. Next 4 years, 12 and a half. Next 4 years, 6.25. Like this, every 4 years, that is becoming half the reward. And finally, in the year 2140 AD, which is more than 120 years to go, at that time, the last Bitcoin will be mined, and then there will be no reward left for mining any new block. Of course, as a miner, you will continue to earn the transaction fee in each block, but no new Bitcoins will be generated after that block, which happens in 2140 AD. Any questions so far? Is it absolutely clear? Now, some of you may also wonder, how long does it take to hash a block? Now, the average block time is 10 minutes. Now, why do I say average block time? Why can't I say for sure that every block will happen in 10 minutes? No, it doesn't work like that. Because nobody can predict how much time it is going to take to hash a block. Because we are running random, see, it's all randomly being done, right? The data is changing, nobody can predict. So what the blockchain software does is it keeps recalculating the difficulty level. So what it will do is every 2 weeks, it will look back at the past and say, what was the average time taken to hash a block? Suppose the answer is it was 12 minutes. Now the software realizes, no, it is only supposed to be 10, but it has taken 12, which means the difficulty level is higher. So it will reduce the difficulty, and then again 2 weeks will go by. Then it will check, it comes to the conclusion, oh, it took only 8 minutes. It will again recalculate. So the blockchain is constantly changing this difficulty level, which means the number of zeros, so that the average time of 10 minutes is maintained. And that is the reason we say average 10 minutes per block. But even today, some blocks will take more time, some blocks will take less time. Questions? Again, simple yes, no, clear, or any questions, please feel free to ask me. Because this is one of the most important concepts. So after all bitcoins will get mined, there will be just transaction fee left. Absolutely correct. After all those bitcoins are mined, which is a total of just under 21 million, which will happen, we are expecting it to happen in the year 2140 AD, but it could go aage piche a little bit. Yes, after that, no new bitcoins will be created. And that is why we say that Bitcoin is a non-inflationary currency. Because normal currency notes which you have, government can print as much as it wants, and that is what causes inflation. But in Bitcoin, the numbers are fixed. All these things that I told you about, the 10-minute average block time, then every 2 weeks adjusting, then 2140 AD, everything getting over, all that is actually recorded in the Genesis block, so we can't change it. And that is why we say Bitcoin is a non-inflationary currency. Clear? Any other questions? Okay. So as we can see from this, in the blockchain, we have an ordered and time-stamped record. So every block is block 1, 2, 3, 4, 5. It's also called the block height. So it has to go in that order. Every block has a timestamp which is there in it, so you know exactly when that block was mined. This concept prevents double spending. Now, you may not understand what is double spending. Now, double spending is a very critical concept. When you take a currency note, can you spend it 2 times? No, because once you give it to somebody, the note is out of your hand. But if I write an email or I make a Word document in which I say, I owe you 100 rupees, and I put my digital signature, you can copy paste that Word document 20 times and now ask me to pay 20 times the money. And that concept is called double spending. But because in blockchains or in Bitcoin, we are using these blocks and we are doing time stamping and ordering, you cannot double spend money. When whatever money you have, so to say, I know money is not the right word to use here, whatever bitcoins you supposedly have, they actually don't exist. It is simply that everybody has an address which is like an alphanumeric number, and that corresponds to some value in terms of number of bitcoins on this platform. But you have a private public key pair, and every transaction you are going to sign with your private key. So it remains totally under your control, but it also means you cannot spend the same thing twice. Yeah, somebody says, please explain more. Sure, I'll definitely do that. But before that, the last point is the blockchain prevents modification of previous records because every block knows the hash of the previous block, so you cannot really modify it. Just to give you a brief overview of what we discussed. So blockchain start at block number 0. In this example, we are starting with block number 17. Every block header, this part is the header of the block. This you could say is the data of the block or the content. Every block knows the hash of the previous block. Every block, when it's to get mined. So let's take a practical example again in Bitcoin. So let's say many people have made lots of transactions within a 10-minute time span. All those transactions are now pushed into the mempool or the memory pool of the blockchain. Then all the memory pool now is going to be analyzed by different miners, all of whom are running these powerful machines. See, I'm simplifying it down a little bit. I'm not being 100% accurate, but to understand what it means. All the miners pick up these transactions, calculate all these hashes, and then quickly try to calculate the nonce. The first guy who succeeds immediately broadcasts the nonce onto the blockchain, and everybody else can see it. And people say, okay, let me verify. Yes, this is all correct. The nonce matches. Done. This block is now mined. Now let me follow this fellow and start with the next block. 17 is done. I'm starting with 18, and all the miners again now start competing with each other for the next one. Sometimes it happens that the same block or the same time, multiple miners get the nonce, and all of them broadcast that we have cracked it. Now suddenly the blockchain splits into multiple blockchains. Next block happens, and after every few blocks the blockchain checks, and if it realizes there are multiple chains running, it will delete all of them and only leave the longest chain. And this regularly happens, and it is all automated by the software. No one has to manually do any of these. Questions? Is it absolutely clear to everyone? No one has questions? Great, because this is the fastest anyone has ever understood this concept. So great, I'm very impressed. Okay. Now, why do we use this word miner? Now, a lot of people get confused that it is like gold mining. So when a miner digs into the ground and he discovers gold, he is doing mining physically and thereby getting some kind of gold out of it. But When we talk about Bitcoin mining, he is calculating hashes by expending computational power and electricity. So that is why they say that Bitcoin consumes a huge amount of electricity, because so many miners are constantly running these machines which consume huge amount of electricity. In fact, that is one of the reasons why Bitcoin mining is usually done in cold countries, because the computers get heated a lot. So if the country is cold by nature, the heating cooling costs are much cheaper. And that is the reason you find a lot of these mining activities happening in those places. So next point, if you read, to add an entire block to the blockchain, the Bitcoin miner must successfully hash a block header to a value which is below the target threshold. That is why the number of zeros. Because when you look at a hash, it is actually it is like a hexadecimal number. And that is why the system keeps adjusting the difficulty level. Any question? Is it all clear? Perfect. Now, in Bitcoin or in many of these proof of work blockchains, we have a concept called a hash rate, which is the speed of mining. That means the number of hashes per second. So, the number of times that hash values are calculated for proof of work every second is called the hash rate. And this is measured in either small k, which is 1000, which is kilo, mega, which is 1 million, giga, which is 1 billion, or tera, which is 1 trillion hashes. So, naturally, the more powerful your computer or your servers for mining, the more likely that you will end up successfully hashing and thereby getting the reward and transaction fee. Is that clear? Any questions? Okay. Now, this is an example of the Antminer T9 Bitcoin cash. So this is for Bitcoin cash mining. That's another crypto which is related to Bitcoin, one of the forks of it. So this is what it looks like. It doesn't need to have all the monitor and all that, because you're not supposed to look at it. It's all automated stuff. So you buy a lot of these kinds of machines. So this is one example. So in China, these are some of the mines. This is what they look like, where you have a large number of uneducated kind of people whose only job is to make sure the computers or the mines are working fine. The power is not getting disconnected, cooling is happening. Another example, this would be a European mine, slightly neater looking. And ultimately, this is what a Bitcoin or a Ethereum mining looks like. It is just a bunch of machines. You don't really need human beings to do anything whatsoever. Is that clear? Questions? Perfect. Now, there's a slight complication when it comes to this transaction fee. When a new Bitcoin block is generated, the information for all the transactions is included in that block. And all the transaction fees are collected by the miner. But it is important to remember that transaction fee is actually voluntary. No compulsion. You can choose how much transaction fee you are ready to pay, and you can bid that. But you know what? Miner doesn't have to accept all your transactions. So suppose you have bid zero. The miner can just choose to ignore your transaction, and it may not just get verified for a very long time. So when you bid the transaction fee, obviously the miner tries to pick people who are bidding the most, and only those transactions go into the block. Well, is mining possible with GPUs? So it's very difficult to answer this question whether you can, what kind of mining machine you make. This would depend upon which crypto you are mining. So whether you're mining Bitcoin, Bitcoin Cash, Bitcoin SV, Bitcoin Gold, or you're doing ETH, there's so many different cryptos you can mine. And many of them can use the same hardware also. So depending upon the software, you would need to do that. Yeah, why Ethereum transaction fee is high right now? I'll tell you the reason. Look, Ethereum was never made to be a speculative asset. ETH, okay, by the way, Ethereum is not the right word to use. Ethereum is the name of the protocol that runs on multiple blockchains. Usually, when the world talks about Ethereum, they are talking about mainnet. Other than mainnet, there are multiple other test networks. Now, in mainnet, ETH is the native currency. Every time that transactions happen on the Ethereum mainnet, you need to pay gas fees, which is in ETH. Now, unfortunately, a lot of people are speculating on the price of ETH, which is shooting up. It in fact went up to $2,000. And unfortunately, because of that, all transactions on ETH, on the Ethereum platform, become very expensive. I hope that's clear about why Ethereum has become, transactions are high because the ETH value has shot up too much. which should never have actually happened. Ideally, ETH should have remained at $1 or even below. And the higher it goes, more and more Ethereum projects are now actually failing and shutting down. Yes, definitely you can mine BTC with these supercomputers, but you need to have access to them. And if you have access to them, definitely you will probably end up winning more blocks and naturally making a lot more money. But please understand, today there's a global competition. And in fact, you have to compete with a lot of people for your mining. Now, I recall way back somewhere in early 2011, you could just use a normal laptop to mine. Not anymore. Any other questions? Okay. Now, one concept we must all understand is this supply being limited or unlimited. The logic is, like I said, in Bitcoin, we are having maximum 21 million which are going to be generated, and already 18 plus million have already been generated. So the number is limited, and which is why its value over time is expected to constantly go up. Can you help us understand how applications work on blockchain or on Ethereum platform? Sure. So what happens is, when we talk about Ethereum, so like I said, let's just consider it now for a simple blockchain, the mainnet. Now, on top of this mainnet, people are running different projects, and each of these projects has a native token, not coin. Now, this is where you must understand the difference between a cryptocurrency coin and a cryptocurrency token. Whenever something runs natively on a blockchain, it is called a coin. So on Bitcoin blockchain, we are natively running BTC, so we call it a coin. On Ethereum, ETH is native, so it is called as coin. But projects, what they generate is not actually the native coin, it is something connected, so we call it a token. And every time that you're creating these tokens, you're basically writing a smart contract. I'm going to show you this later when we actually install our own blockchain from scratch. And that is the time when you set a separate token, and anybody who wants to use your project for whatever it is doing, they will be then buying those tokens also. But always remember, no matter what tokens you use, when the transaction is pushed to the Ethereum platform, the fee has to be paid in ETH only. I hope that's clear. So I've also actually written a lot about how the Ethereum ecosystem works, how the Bitcoin ecosystem works. So if you just follow me on social media, on LinkedIn, I've put a lot of these step-by-step details, so you can always have a look at them also. So miners can focus only on those transactions that are beneficial to them and can create fraudulent. No. Yes, they can concentrate on what they want, but that doesn't create a fraudulent chain. Please understand, every transaction which you push has to be digitally signed with your private key. So nobody else can sign a transaction for you. Only your private key can do it, which is what you are supposed to have. So in fact, Elon Musk made a recent statement that if a crypto app does not give you control of your private key, don't ever use it. And he's correct. You are supposed to have it. You are always supposed to maintain and hold your own private keys. And you'll be surprised to know that private keys can actually be written on a piece of paper. So in fact, I've written a book called as the Future Money Playbook. You can just download it for free. Later, I'll put the link here. I've actually shown photographs of how you can, on a piece of paper, also write down your private keys and address. So you can keep it as safe as you want. But remember, it should always be with you, your private key. Any other questions? So no, they cannot do a fraudulent transaction. Any other questions? Then there are some common questions that I'm always asked. What is the difference between the Bitcoin blockchain and the Bitcoin cryptocurrency? So as you would have understood, the blockchain is what we call as the blockchain. You can say in capital letters the, because it was the first in the world. And on top of that, the native currency is called BTC. So whenever you talk about the currency, it's not Bitcoin, it's BTC. Bitcoin is actually the name of the blockchain. Right now, what are some of the applications that are popular on Ethereum? Sure. So in Ethereum, we usually find two kinds of projects. One is called as fungible and one is called as non-fungible token. Fungible means all units are the same. To give you an example, let's say you have 10,000 rupees in your ICICI bank account. All those 10,000 are the same unit. There's no difference. I have 5,000, you have 10,000. It is ultimately all the same thing. It's rupees. There's no difference between 1 rupee of ICICI bank and 1 rupee of Axis bank. So that is what we call as fungible. But non-fungible is when each of them is different. So when you take, let's say, a piece of art, like a painting, and the digitized version of that is put on Ethereum, that becomes an NFT or non-fungible, which basically means each token is different because it could represent a different asset. And of course, when we talk about the applications today, the number one kinds of applications are what we call as DeFi, decentralized finance. Now, in the conventional world, finance is very centralized. Banks, stock exchanges, all these central entities manage it. But when we put them on a blockchain, nobody knows who they are dealing with. So everything is decentralized. Anybody can do anything. And those are called DeFi transactions, and that is what is most popular. In DeFi, we have derivatives which are done in a big way. We have liquidity providers, and these are today, the volumes are in trillions. You will be surprised to know, but Ethereum handles more than $1 trillion worth of transactions every quarter. And most of these are going to be the DeFi kind of transactions. I hope that answers your question. Does anyone else have a question? Okay. Then we also have the blockchain versus other blockchains. Can you kindly briefly one more use case of NFTs? So yeah, so like I said, one is things like CryptoKitties or these kind of digital art. That is the number one project that we today find in the NFT space. Digital art is what I feel is the number one thing that is going on. Other than that, there are a few other tokens, NFTs also, which are available. Like for example, some people are converting the shares of companies onto the blockchain. So this we usually call this concept as a wrapped share, WRAPPED. So a wrapped share means Bitcoin, for example, is running on a separate blockchain, but there is a custodian who holds the Bitcoin in some other place, and against it issues a token called WBTC on the Ethereum blockchain. Similarly, you can do it for shares of companies. So as an Indian, you may not be able to buy Amazon or Facebook or Apple shares because it's listed in the US, for example. So what do? You could go to these DeFi platforms and say, I want to buy Amazon shares. They will give you this kind of a token, which is backed by the Amazon share held by somebody in the US. And those are other examples of NFTs. Okay, how 51% attack? So if you look at the original Bitcoin white paper, in fact, I would strongly recommend that you must read the original Bitcoin white paper. Now, in that, they talk about that as long as a majority of the miners are honest, the system will be foolproof. But 51% means if more than half the miners suddenly become rogue, or they try to crack the system, then these fake transactions and all could start to happen. We have not yet seen an actual 51% attack succeed on BTC. But if that happens, that could be disastrous for the price, because then that would be a real break in the chain. Dust attack. So what happens is that, let's say you are having X number of BTC and now you're making a payment. Some amount comes back to you as change. When you pay money in a note and you get back some chiller or change. Similarly, dust is these small, minute amounts of microscopic coins, you could say, like 0.001, which come back. And in a dust attack, you could send it in such a way that many such transactions of dust start to take place, and that starts to slow down the network. And in fact, that is the reason we have native tokens. That the Ethereum people also realize that if we do not force people to pay a charge for every transaction, hundreds and thousands of transactions will happen all the time, just for random bringing down the system and launching a denial of service attack. And that's the reason every transaction costs you money. So if you're trying to DOS the system out, it's going to be very costly for you. Any other questions? Okay. Then we have the concept of other blockchains. So Ethereum is an example, Neo, QTUM, Cardano. There are many different public blockchains available which people can run projects on. So Ethereum is not the only one. People use others also. Then there is a concept called private, hybrid, and public blockchain. So Bitcoin is public. Ethereum is public, which means anybody in the world can become part. You don't need to take permission from anyone. Private is when one organization runs it, which according to me is not a sensible use case. It doesn't make any sense for one organization to run. It is much better that you run your own private database. However, hybrid is an interesting concept. Hybrid is where a bunch of people come together. So 20 banks can come together, circulate nodes with each other, and then carry out, let's say, global cross-border remittances. So these are the three kinds of blockchains: public, private, and hybrid. Any questions? I've also given links. You can later on check out what Neo and QTUM and all that do. Any questions as of right now? Okay. Now, Why blockchain? One of the most important features of why we use blockchain is it removes the characteristic of infinite reproducibility of a digital asset. That is the number one point. That I could digitally sign a Word document, but somebody can make 20 copies of it. That cannot happen on a blockchain. And every asset can be very carefully controlled. And in fact, I'm going to show you a demo of how we actually build these assets. So that is the reason that we actually use blockchains. Any other questions? Now let me just broadly and quickly discuss some of the basic types of encryption. So one is what we call as the symmetric encryption. In symmetric encryption, the key that you use, so if you can see the key here, this is the plain text, encrypted becomes the ciphertext, which you cannot read. But the same key can be used to decrypt it and get the plain text back. This concept is what we call as the symmetric encryption. Let me give you a simple example. So let us say there is this sentence, I fear not the man. So this is a Bruce Lee quote. Now, when I use the AES algorithm, Advanced Encryption Standard, it is considered to be the strongest symmetric algorithm in the world today. When I use it, it generates three things, of course, four things. Firstly, the password, which could be this. Secondly, is something called an initialization vector, which would be something like this. Thirdly, something called an authentication tag, which could look like this. And fourthly, the encrypted version of the data. So imagine this sentence has now become this. So obviously you cannot understand this unless you have these three things: password, IV, and tag. So in blockchains, we use this a lot. Whenever we want to decrypt the data, we have to provide four things: the password, IV, tag, and the encrypted data. Questions? Is the concept of symmetric encryption absolutely clear? I'm not seeing any response. I hope I'm clearly audible. Can someone please put a yes, no, so that I know that all of you are following? Okay, great. Thank you for that. Now let me continue. Then we have this concept called asymmetric encryption, where this plain text can be converted to the ciphertext using something called a public key, but for decryption, we need something called a private key. Now, this is very similar to a bank locker. When you go to the locker, you have one key and the bank manager has one key. To open the locker, both the keys have to be used, but to lock it, only one key is needed. Same concept here in asymmetric. Everybody, when you generate a key pair, you get private key and public key. The public key you distribute to the whole world. The private key you keep with yourself only. And whenever you want to decrypt something which is encrypted to your public key, you use your private key. Let me give you a simple example. So I take the single word hello, and when I encrypt it, it becomes this whole blob of text. So this I am using something called the RSA algorithm. And when I use my private key, only then will I be able to convert this back to the original message hello. So when you want to send me the hello, you will get my public key, encrypt the word hello, and send me this by email or whatever. I will then use my private key, run it on this, and get back the word hello. So all of you must be knowing about the concept of SSL, the secure socket layer. Well, that also is an application of asymmetric encryption with symmetric encryption. I hope that's clear. Any questions? Okay. Now let's move on. And then we have the final concept, which is called the digital signature. Now this is very, very popular today. In fact, if you file your income tax returns online, or you are director of a company and you are ever, signing the balance sheet and all that, you are using digital signatures, although you many times may not even realize it. Many people just give that dongle of their signature away to the chartered accountant or CS. Well, in that case, he's putting the signature for you. But the concept is very simple. You take the original text, sign it with a private key, and anybody in the world can verify it with your public key. And somewhere in the middle, hash functions are used, but that's not important for you to understand right now. This is what a digital signature actually looks like. So now in blockchains, we find that RSA is not commonly used. ECDSA is used. That stands for elliptical curve digital signature algorithm. This is what an ECDSA private key looks like. This is what an ECDSA public key looks like. Again, this is an example of the sample data, and then you will generate this digital signature. Now, because this is a signature and not encryption, we are not encrypting the text. Once your software generates the signature, it will send the original text plus the digital signature forward. And whoever gets it to verify, they will simply use this signature and this text and your public key, and they will be able to verify whether it is actually signed by you or not. That is the whole concept of a digital signature. Questions? Or if you can just key in clear so that I know that it's all clear so far. I hope it's all clear. How can we see our own? Yeah, that's a very good point. So now it depends upon the blockchain. Now, many times what happens is we use, for example, an app, and based on that app, it is going to generate the keys. In that case, your keys are inside your app, but you may not be able to see them. So the simplest way to do it is you can go to bitaddress.org, and there you can just move the mouse around on its on the screen, and it will generate the private key and give it to you, and then you can download and keep it with yourself. That's the simplest way to actually do this. Difference between asymmetric and digital. Yeah. So the concept of asymmetric is to encrypt the data so that nobody can read it. Confidentiality. The concept of digital signature is to sign and verify, to introduce the concept of uh, non-repudiation. You have signed a legal agreement, you should not be allowed to later say, no, no, I didn't sign it. So asymmetric encryption and digital signatures work on the same technology, private public key pair, hash functions, but their purpose is different. So in a digital signature, you use the private key to sign so that you are authorizing a transaction. In asymmetric encryption, somebody else uses your public key to encrypt the data and you decrypt using private key. So that's the basic difference, the function or the logic behind it. Encryption for confidentiality, digital signature for non-repudiation. I hope that answers your question. Any other question? Okay, let me move ahead. Okay, so now somebody had asked a question about how do we hack into a blockchain. So now I can sort of give you one of the first level answers on that. For that, we need to understand what actually is there when we talk about a blockchain solution. There are multiple layers in it. So first step, you are going to need a server. So let's take an example of an Ubuntu server. On that Ubuntu server, I'm going to show you a demo of this very soon. And those of you who have already downloaded multi-chain, you will be able to follow on your own server. But base, we are having some server. If that server is not properly hardened, then you can hack into that and the blockchain's history. See, ultimately, you must remember the blockchain is not like a Rajnikant. Rajnikant is unhackable and unbeatable. Blockchain is not like that. There are multiple levels of insecurity or vulnerability in it. And the number one point is the operating system. No, we are not going to do live hacking of it. But now Ubuntu can be hacked. If it is not properly hardened, later I'm going to discuss how you even harden Ubuntu. That becomes one level of hacking. Then once you have set up this blockchain, you have the keys and the data which is in the picture. Now that is, you have your ECDSA keys. You could have RSA keys for encryption and the encrypted data. So that becomes the second point of vulnerability, that data could be stolen, hacked. So let's say the data is flowing between the nodes from one node to the other. Now when it is flowing ultimately through the internet. If that is not encrypted, then that's the second point of vulnerability that you get, which is also sometimes called as the packet sniffing. So if you're asking questions on hacking, you obviously know all this, but just to broadly tell you, we use a concept called ARP cache poisoning. So there is something called the address resolution protocol. So you are sitting at an airport, lots of people are using the Wi-Fi there. You set up this software which can then fool everybody into thinking that your computer or your router is the main fellow, and all the data now starts flowing through that. And that, because of ARP cache poisoning, you have fooled everyone into believing you are the original hacker or the original router, and all the data flows through you, and there you can actually copy the data, including SSL data. So that becomes a very major level of hacking, and that's the simplest way to hack into a blockchain, so to say. Then you have the blockchain framework. So now you have installed multi-chain, Ethereum, whatever protocol that you are using. On top of that, usually you have an API layer. And then finally, you have your web and mobile application. That is the biggest point of vulnerability. Can make it hot. That is the biggest point of vulnerability if you are able to hack into the web application. Now that's a standard web app. So you can use the standard attacks, even an SQL injection may work, and you've actually hacked into the blockchain. So please remember, whenever you use the word blockchain hacking, there are multiple things you could end up hacking. The core operating system, the data layer, the data while it is flowing from one node to another, or the end application. And of course, in terms of simplicity, I would say the end application is the simplest to actually hack. Any questions? Is it all clear? Again, I'd need to hear a yes, no, or a question. Can someone respond? Okay, great. Now let's take a look at a simple layout for a blockchain application. So what you see here within these dotted lines is the private network. What you see outside is on the internet. So now let's start from here. So you have these authorized users. Let's say they are customers of a bank, and the bank is using blockchain, and this is the bank's node. So if there are 10 different banks, each of them has his node, and to that node, they are connecting to their private network. And then this is the bank's customers here. So now there is a load balancer here. The load balancer is connected to your app subnet. You are having the caching server here. You are having the node outside. You are having the API server here. And then you are having your database subnet here. And this whole thing comes under your private network. So now you will realize by looking at this that this is like any other kind of application. So yes, blockchain applications at the end of the day are all going to function in a very similar way. But the blockchain part of it is a little different. Everything else is normal. So all the points of vulnerability that you have in a regular application, almost all those points of vulnerability you are going to have in a blockchain application also. Questions? All clear? Let me know if you have any questions. Okay, great. Now, actually go into some practical point of discussion. Now, how do we set up and secure a blockchain? So first step is that we will set up and harden at least two servers. So one is going to be, we could call it as our main server. For sake of simplicity, let's just say blue and green server. So a blue server is the core where we are going to actually set up the blockchain initially. So our Genesis block, you remember Genesis block? The Genesis block is the first block or block 0. So we are going to set that up on the blue one, and then we are going to set up multiple nodes on the green one, which you can connect to. Somebody's asked a question here. Can we generate private key from public key? No, you cannot. The private public key generation starts from the formula. So we use prime numbers for this. I have also written a short white paper on the RSA algorithm. If you're unable to find it online, just email me on rohasnagpal@gmail.com. I'll send it to you. So you'll realize how the mathematics goes. It starts with two random prime numbers. And then the end result, somebody says no. I'm not really sure what you mean by that. Can you clarify whether you are understanding or not? Okay. So that mathematical formula then finally leads to the generation of the public and the private key. You cannot take one of the keys and then generate the other one. That's not how it works. It has to start with those prime numbers, and then the two keys are the end result of it. So after we set up these two servers, which are hardened Ubuntu servers, for example, then we will install a blockchain framework. So there we have multiple options. You could use multi-chain, Ethereum, so many others. You could even use Bitcoin. For today's demo, we are going to use the multi-chain. Okay. Somebody's asked a question, what is a load balancer? So what happens is if many people are trying to access your application at the same time, the system may get overwhelmed and shut down, or it may slow down. So what a load balancer does is, you may have 4 servers at the back. The first transaction that comes in is pushed to the first server, second to the second, third, fourth, fifth transaction goes back to the first. The load balancer is the guy who's going to balance this load. And if one of those servers goes down, he will pass on to the others. So that's the job of the load balancer. It is not specific to blockchain. All web applications use load balancers. Then once we have installed the multi-chain, we will create the blockchain. Then we will connect to the blockchain. Then I will show you some basic commands which we can run. And finally, I will show you the most important use case, which is asset management. So we are going to see how we create assets and how we can send them around. Questions? Because now we begin with the practical session. So if you have questions, now is a good time to ask them. Okay. So I'm presuming all of you are clear with everything so far. Now, when we set up a core server, for today's demo, you can just set up a simple one. But usually when we do it for a production run, as far as basic Ubuntu hardening is concerned, there are at least 11 steps that you need to follow. So you need to set up a user account because you don't want to run the blockchain or these applications as a root user. Because if someone gets in there, everything's over. So you set up another user with limited permissions. Then obviously you need to make sure all the packets are updated. So your system is not having any outdated package. Otherwise that could be very easy to hack. Then you set up password aging. Sorry. The meaning of that is after how much time people are forced to change their password. Then you set up the swap partition, you disable ping requests and IPv6, you verify that your open SSL version is the latest, you secure the shared memory, you secure TMP, where TMP, you set your security limits, and final point, you have to ensure that you're not vulnerable for bash. This was a very major vulnerability which came out a few years ago. So these are usually the 11 simple terms, but I don't want to go into this detail right now because we are talking about the blockchain, not so much the networking. Now you could use Red Hat, you could use Mac, you could use Windows, you could use any kind of a operating system that you want. Blockchains run on all of them. But let's see how we actually install. So first of all, we need basic system requirements. So for multi-chain, you need 64-bit. Ubuntu works, CentOS works, Debian works, Fedora, Red Hat. Windows also is supported, 64-bit. Mac also is supported. And you'll be very interested to learn that the RAM requirements are very low. You need just half a GB of RAM. Blockchains are not RAM intensive. The misconception comes because of Bitcoin. See, in Bitcoin, there are miners competing against each other, millions of them. And that is the reason we need so much computational power. But when we talk about, say, a private blockchain or a hybrid one where people are not competing, even a half GB RAM is more than enough to actually run it. Okay. And then you need 1 GB of space, of course, as the data in the blockchain increases. So for example, in blockchains, one limitation you could say is that you have to maintain all the data from day one. So the Bitcoin blockchain, I think, started in 2009. Now today is 2021. If you want to set up a full node, you are going to download all the transactions which have happened from 2009 till today. And that's like more than 100 GB. And as in future also, all transactions will be broadcast to all these nodes. So that is when you will need more and more data hard disk space. For right now, 1 GB is enough. Okay. So now what I want you to do is, those of you who are doing it along with me, please log into your server, which you have already set up, or you could even do it on your laptops, and you need to run these 5 lines. So you need to run cd/temp. You need to do a wget with exactly this. So if you have downloaded this PPT or PDF, you can actually copy paste the commands from here. This one, change directory, and then finally move it into this place. Now, for sake of convenience, the next few slides, I'm going to talk about something called the blue server and the green server. I would request if you can also note down this IP address, because this IP address 159.65.149.21 is the IP address of my main node on which my blockchain is running. So when you set up your own, you are going to connect to that particular block or that particular node. So you can note down the IP address. So I'll give you a couple of minutes if you are actually running the commands. In the meanwhile, if anybody else has a question, please ask me. We'll wait for a couple of minutes. Any other questions so far? Okay. So great. I'm presuming you are all setting it up. Whoever has the node running, you can use your Mac laptop also normally, which can connect to it. So what we are setting up is you could sort of consider it like a private blockchain because you are not going to get mining rights. The mining rights are reserved in this blue server that I have set up. Okay, somebody says they're a tech newbie, will just watch. Absolutely no problem. You can just, let's just give it another few seconds. Okay. Now, this is what the command would look like. So I hope all of you are able to see this clearly. So here I've logged in from my Mac laptop. I did an SSH root at my IP address. So you would do the same thing. You would run it on your own server. So what would change is this IP address that you see, you would use your own IP address because you can only log into your own node. Then I entered the password. This is the Ubuntu system that I've logged into. And this is the standard Ubuntu disclaimer that comes. And now it shows that I'm logged into this server. Now the name of my server is test chain. So it says root at test chain. Now I'm logged in. I hope that part's simple. Okay, some questions have come. Let me just see. Can you tell us about Prime Chain? How is it different from Polkadot? Yeah, that's an interesting question. So Prime Chain is actually an API layer. What we do in that is it's a downloadable software. When you download that and you run it on a server, it sets up the blockchain, does all the security and hardening, then sets up an API layer, then sets up a UI layer on top of it. The user interface layer with the mobile app, the progressive web app. It also has social login enabled like Google login, Facebook login, and that whole thing is set up, but sorry, in a private kind of a scenario. That means you will use Prime Chain to set up your own blockchain. Whereas something like a Polkadot is a global public blockchain which you can directly connect to and start using. Prime Chain is not a public blockchain. It is a software to set up private or hybrid blockchain. I hope you get that answer. Then what do you think of blockchains such as EOS where you own resources and spend them to run dApps rather than consistently buy? Obviously, it is much better. In fact, the biggest problem with Ethereum is the rising cost of ETH. And that already some startups have shut down development on Ethereum because they say that the transaction costs have become too much. I mean, it is almost gone up to $20 per transaction. I mean, it is impossible to sustain anything where you're spending $20 a transaction. So yes, anything which doesn't have that transaction cost is the only way forward. Is this way of running dApps better for the future of the blockchain? Can you? Yeah, so it is naturally much better to run in scenarios where the transaction costs are as close to zero as possible. But please also understand why have transaction costs been put? Transaction costs have been put so that people don't spam the network or DOS the network out. So transaction fee also serves a useful purpose. So if you take away the transaction fee in a public scenario, then every day you will have DOS attacks which will bring it down. So transaction fee has a reason, but it also causes a problem when the cost becomes too high. So yeah, it's a sort of quite a strange problem that Ethereum is facing. Now that we are logged in, we go to the next step, these commands that I showed you. So we ran all of them one by one. And finally, that part is completed. All of you may have also done that. Now I'm showing it to you on the green server because basically I've set up two servers. So one is the main one where I am running the blockchain and the Genesis block was generated. Then I set up another one which is connecting to it. So now in the next few slides, whenever you see blue, remember blue is the main one and green is another node just like the node you are running on your server or laptop. So blue is the big guy, green is the small guy, and you are also connecting like a small guy because you don't have the mining permission. What platform PrimeChain is made of? It is made on multi-chain, not on Hyperledger. Hyperledger is actually not a true blockchain. I believe it is a distributed ledger, and multi-chain, it runs on Bitcoin, actually on the Bitcoin core which has been modified, and I consider that to be the true blockchain and not a distributed ledger. But again, you feel free to disagree with me. See, I am more old-fashioned when it comes to blockchain. So I believe that the word blockchain should only be used when you are running proof of work. Everything else I would call as distributed ledger. So even when Ethereum moves onto proof of stake, we would call it then a distributed ledger. And I'll tell you the reason. It is not my invention that I'm giving this reason. The Bitcoin blockchain white paper, for the first time in the world, used the word blockchain. In fact, it didn't say blockchain, it said chain of blocks. But it spoke about proof of work. So if we are now changing proof of work, we can no longer call it blockchain. We should call it distributed ledger. I mean, it's just semantics. Okay. Now let's go ahead and actually create the blockchain, right? So what I have done is I have created it by running. So multi-chain is very simple to set up. Once all the software is downloaded, all that you need to do is run multi-chain -util create test chain. Now test chain is the name of my blockchain. You can call it whatever you want, but when I set it up, I called it test chain. After that, I run one command, multi-chain D. It's not a spelling mistake. It is with this D at the end. The name of my blockchain space hyphen daemon. When I run this command, so let's show it to you here. So when I run this command here, you see multi-chain -util create test chain. So this is created, and then as you can see, it shows that okay, fine, multi-chain is being set up here. Then can you read starting up node? So again, on your own downloaded version of the PDF, you can read it. So it says that the node is starting. It says looking for the Genesis block. Then it says Genesis block found. Please remember, Genesis block is block 0, the first thing. Everything begins from that. So like the universe started with the Big Bang, so the same way the blockchain started here with the Genesis block. Now it tells you that other nodes can connect to this node using this particular command. So now all of you, if you are running it on your laptop, you will need to run this command, multi-chain D test chain at 159.65.149.21 /8363. 8363 is the default port number. Of course, you can always change port numbers. I have not changed any of the default parameters. And then it is going to listen to API requests on 8362. So you are connecting on 8363. 8362 is where API requests will be running. That uses something called the RPC allow, which is the remote procedure calls, but we don't need to go into that much depth. And then finally it says node is ready. And it's up for me to now run more commands. So again, I'll give you a minute or two. If you are setting this up live, please only run this line. Multi-chain D test chain at this IP address : the port number. Somebody said, what is blacklist coin? No, I have not heard about this. So if somebody from the admin team is here, can you please Google blacklist coin and just write an answer? I have not heard of this particular coin before. Again, I'll give you a minute to run that particular command. Yeah, you can even copy it from here. So what I call as the second server, you are part of the second server. So you can simply copy paste this command, multi-chain D -test chain at IP address : port. Okay. So now what happens is, after you have done this, I will now have to grant you permissions. Now this is a very important concept. I want you to focus here. This is a blockchain address. So irrespective of which blockchain platform or framework we are using, you're always going to have addresses. So Bitcoin addresses are there, they may look different. The number of characters may be different, but ultimately they all will be looking like this alphanumeric number. So everybody who creates a node, right, that person gets an address for that node. And that is that node. Can we run this command? Yeah, you can use terminal. Now, everybody who connects a node, when you set up multi-chain on your node, it will give the node address. You have to actually send it to me by email or whatever form you want. And after I receive it, I will then log into my system and I will grant you the permission. So I will go with this command, multi-chain -CLI. So in fact, what I can recommend is better don't do it live right now. Follow the here, and I will keep this server on for some time. So after this session is over, say maybe till Sunday, I can keep it running. So during those next couple of days, if you want to connect, After you have gotten your address, just email it to me at rohasnagpal@gmail.com. So if I can request the admin team, can you just put my email address on the chat so everybody can get it? Yeah. So you can later follow the commands here, and then once your address is generated, just email it to me. I will then give you permission and you can actually use it. After I grant you this permission, then on your server you will run this multi-chain D space test chain space hyphen daemon. After that, you can run this multi-chain hyphen CLI test chain so that it becomes easier for you to run commands. After you have done that, this is why it looks like this. So when you set up the multi-chain on your server, it will show you this address here. Do you see this 1C? It will show it to you and you can just simply copy paste from there and email it to me. So you don't have to do any guesswork. It will just straight away pop it up. So far, have all of you understood? I need a simple yes, no. Is it all clear? I need a, yeah, great. So once you have run this in, so whenever you see green, that's what you are going to see on your system. Now, once you send it to me by email, what I'm going to do is, notice here, I'm going to say multi-chain hyphen CLI, test chain, which is the name of my blockchain. Then I'm going to say grant. Then I'm going to paste your address, which continues still here. And I'm going to say connect. What does it mean? It means that I have given your node the permission to connect to the blockchain. So in multi-chain, there are 6 different kinds of permissions that you can have. Connect is the most basic one, which allows you to connect your node to the blockchain. Then there is send, receive, admin, mine, different kinds of permissions that come in. But most important is the connect permission. So when your node connects to the main blockchain, it needs connect permission. And that is the permission that I will grant it. After that, on your node, you can create hundreds of addresses. And I can then grant each of those addresses different permissions. Some I can give the send permission, receive permission. All that is customizable. So blockchains are highly customizable when it comes to permission. And that's also very important to remember, because if you end up giving the wrong permission, again, you're opening it up to an attack. So if some unauthorized guy ends up getting admin permissions or mine permissions, your blockchain is ruined. So we have to be very careful what permission we give anybody. Questions? Is it all absolutely clear so far? This part that I've granted permission. Now you will notice this long alphanumeric number here. Now, what is that hexadecimal code that you are looking at? That is the transaction ID. Every single blockchain transaction has to generate an ID. If the transaction ID is not generated, the transaction has not gone through, which is why you cannot hide a blockchain transaction. Everything, when it goes through, generates a transaction ID. And that is the only thing which proves that that particular transaction has actually happened on the blockchain. So everything that we do will generate these transactions. You don't have to save them. It's just proof that the transaction has gone through. Sometimes it may take time for it to happen. So like when you're creating an asset, it may take a few seconds to show up, but till it shows up, transaction has not gone through. Does blockchain have stuff like a normal computer does, like ring? No, see, okay, so it's very difficult to compare it to a regular computer because you are running this on top of the computer. So you are running the server like a normal Linux server. On top of that, you are running the blockchain as a software. Then the blockchain, when it starts to run, becomes like an instance of it running. Then it only supports limited commands. So whatever I can run here are multi-chain commands. Nothing else will be allowed to run. Okay. Let's proceed. So here again, now I've shown it to you that on the green computer, you will again see once the permissions are there, you will see node ready. Then on both, I run this multi-chain hyphen CLI space test chain. The reason I run that command is that after this, now we are entering into something called the interactive mode. So every time I don't need to keep entering the multi-chain name, I can now straight away run my commands. So in your system, you should just see test chain, colon and dot here. Now let's run some very basic commands. So the first command is get info. What does it do? It shows you all the available commands. Help obviously gives you all the permissions. List permissions. So this will show you all the addresses and what permissions they are having. We can see list addresses, get peer info. Now this is a very interesting concept, peer info. Who are the peers connected to me? That's the answer that you are going to get. I apologize if I sound, no, you don't sound stupid at all. Please feel free to ask any question. A lot of the people in the call today may be having very basic knowledge, so please don't forget, don't feel shy asking questions. Then get blockchain params and get runtime params. So first I'll explain what is the meaning of get peer info. Every node connected to the blockchain is called a peer. So when I run it from my node, it will show me all the other nodes details. When you run it from your node, it will show you all the others except for you. So all the other peers connected to you. Now multi-chain comes in two versions. One is the community edition, which we are using right now. There, the data between nodes is not encrypted. But if you use the paid edition, in that case, the enterprise edition, all the data flowing between nodes will be encrypted. Getting blockchain parameters means it will show you a list of the parameters of the blockchain and runtime params. Now, you'll be surprised to know that even once your blockchain goes live, some parameters can be changed. And that is where the difference comes between blockchain parameters and runtime parameters. Blockchain parameters are usually the ones which cannot be changed in future. Runtime parameters are the ones which can be changed in future. And that is what enables us to keep updating our blockchain in future. After all, technology is not going to remain static. So how do we keep upgrading our blockchain? That is where runtime params come into the picture. Any questions? Okay. Now then we are also going to see the grant. Grant gives permissions to people. So in multi-chain, we can give connect so that you can connect your node. Send, which means you can send assets. Receive, which means you can receive assets. Then you can create data streams. So a data stream sort of is like a database within the blockchain. So, suppose you want to store data. Let's say you want to store KYC data in encrypted form. You will then create a data stream, and then you will be able to put data into it. So the permission to create a data stream can be given separately to an address. You can get the permission to issue assets. You can mine, that becomes a very important part of the blockchain. You can activate different functions, and you can become an admin. So these are the 8 different permissions. And then of course you can list all the permissions given specifically to an address. So let me start with the first one. So first, if I run get info, you have to simply type in the word get info and hit enter. It will show you all the detailed information about this blockchain. Now, some of the points I want you to focus on. Version, this is 2.1.2 multi-chain. Node version we can ignore. Edition is community edition, not the paid edition. Protocol version is given here. The name is test chain. We had given that name. Protocol is multi-chain. If you are running Ethereum, protocol could show Ethereum. In multi-chain, you can even run the Bitcoin protocol. Port number shows up to you here. Now, a very important thing is called the burn address. And it's a very weird looking address. Have any of you ever heard of the word burn address? Let me explain what it does. It's a very interesting concept. See, in a blockchain, we cannot delete. We can only add data. So suppose we want to delete some assets. No, we have created 10,000 shares. But now we want to make it 9,000. We realize 1,000 was by mistake. Or we want to now destroy the shares. There is only one way to do it. And that is by sending that many shares or units or assets to the burn address. So by default, every blockchain will have one burn address. The meaning is this is an address which has no known private key. That means nobody in the world can access data or assets sent to that address. Nobody, even the creator of the blockchain cannot. That is the reason it is given the name burn address, shown to you here. Yes, it is in a JSON format. In fact, JSON is supported by multi-chain. The output also is given to you in a JSON format, which is why it is very easy to integrate multi-chain into any JSON supporting application. And that's the reason I'm a big fan of multi-chain and not any of the others. So whenever you want to destroy an asset, send the units which you want to destroy to the burn address and it's gone. Nobody now can ever access it. I hope that part is clear. Any questions? Okay, great. Then other than burn address, there are lots and lots of other things, blocks, we can ignore. You remember we spoke about the difficulty level constantly being adjusted so that the block time of 10 minutes is maintained in Bitcoin. Well, difficulty level is shown here. Pools we can ignore for the time being. Yeah. So I've broadly told you, no problem if you ever want to see what the other terms means. So then in that case, you can go to the multi-chain side and every single API is documented in detail. So you can see the meaning of each of those terms. Now let me run another command which is called list permissions. So without space, just enter list permissions and then it will show you the different addresses. So there is an address which begins with 1 capital C and 1 capital N. Now this fellow, 1 capital C, is the address of that green node. So he has only the connect permission. And my address on the blue node is 1N. It has mining permission, admin permission, activate permission, and few other permissions which if you scroll down you will be able to see all of them. So this shows us all the addresses and what are the permissions that they have. Yeah, it's continuing. So it also has the is mine set as true. Then if you do it on the green, then it shows you only your address, which is this starting with the 1C. In your case, it will not be 1C, it will be something else. And is mine means it's of that particular node. Then another command that you can run is called the get peer info. So like I explained to you that it will show you all the other nodes that you are connected to. And then for each of the nodes, it will show you their address, their port number, their IP address is of course shown to you here. This is the main of mine. Then all these, okay, we can ignore for the time being. None of them are so critical for you to understand. One thing to remember, because we're using community edition, encryption is false. So data traveling between nodes can be sniffed by somebody. So later when you log in on your node, you can do get peer info and see details of your node. So that would be something like this. Same again, you can see all the data. Okay. Then we have another one which is called get blockchain params or the blockchain parameters. So here again, chain is multi-chain. By default, a stream called root is automatically created. After that, you can create multiple more streams. Maximum block size you can ignore. Okay. Ports are given to you here. Okay. Then this is a very, very important part. All the common 8 permissions which are there, what is the status? If for any of these I had kept it as true, automatically anybody then would be able to spin up a node and connect. So if we were to look at a Bitcoin scenario, all these permissions, of course Bitcoin doesn't have all of these permissions, they have their own, but in Bitcoin or in any public blockchain, each of these permissions would be set as true. But because I'm going with a private or a scenario, I will keep each of them as false and then I will one by one give permissions. So this is a very crucial part, and again a mistake here can destroy your blockchain, is that you have to understand the business requirements, and based on that all these parameters are set up at the initial blockchain creation time. So again, you can set up this complete detailed file, tweak each of those parameters. I think there are about 60 to 100 different parameters. So yes, the first time it will take you a very long time to do it, but once you get the hang of it, you can use the same template. And that has to be set up right in the beginning. Okay. Yeah. So you remember we spoke about in Bitcoin every 10 minutes, the reward, every 4 years, the reward is reducing in half. So it started with 50 Bitcoins per block and it's gone down to 6.25 and slowly it will become 0. That is set up here. Right on top, do you see record halving interval? So in seconds, you can set up that interval also. That after how much time the reward should become half. Other than that, there are a whole bunch of things, but since many of you are new to this, I don't want to go into details of all of them. But yes, there's a whole bunch of parameters that you can see. If later you have any problem understanding a parameter, please feel free to email me. Okay. Then I can run something called list permissions. It shows me all the addresses and their permissions. I can list the miners. That means which are the addresses which have mining permission. So only one, that is this one capital N. Only that fellow or that address has mining rights. Then we go on to the asset management. So first we will create an asset. Before I go into that, any questions? Is it all clear? I'm going into the final stage, which is the asset part of it. So if there are any questions, let me have them now. Otherwise, okay, all fine, great. Now, when we create an asset, before we do that, we need to first run these two commands to identify which address we should use to create that asset. So we will run list permissions issue and list addresses. And the logic is that any address is suitable if it appears in the output of the first command and the second command together with this is mine equal to true. So only addresses which satisfy that condition should be used to create. So we ran this first command and we ran the second command. You can see in this one, 1n is the address. Again in this one, 1n is the address. Is mine is true, which means it's on my node. Now I can create an asset using this address. Please remember, you can set up unlimited addresses on each and every node. Now, this may look a little complicated, but it's not. Let me explain it to you. The command is called issue from. Then we put the first address, that issue from whom? So this address. Next is issue to whom? And that is the second address. They can be the same or they can be different. There is no rule on that. In this example, I am issuing from this address to itself. So an address with the permission can issue assets to itself or to any other address which has received permission. Then you will notice a JSON kind of a thing where a curly bracket opens. Then in double quotes, we put any parameter that we want. It is not fixed. You can call it whatever you feel like. So you can call it name, you can call it company name, you can call it asset name, whatever. So in double quotes, we give the name of the parameter. Then next to it, after this colon, you have to follow this exact. Now in this double quotes, you can write whatever you want. So I have said Alpha LLC, which is a company. Their series A is the name of this asset. Then comes open, whether it is true or false. What is the meaning of that? If you set an asset as open, you can create more units in future. So you create 10,000 units now, you can create 5,000 more, 30,000 more, any amount. But if you create it as false, you can never create any more units of that asset. So be very careful when you create an asset. In this example, because it is equity shares of a series, I will say false, because in future the company will do series B, series C, startups when they raise funding. So I have kept it as false. Then it says how many units. So I say 50,000. Then it says how many digits in decimal do you want to support. Now you may know that in Bitcoin it goes to 1 billion. It is called a Satoshi, 0.00001. So you can decide how many decimal points you want to support. Now because I'm doing for equity shares, you cannot break an equity share into parts. So I'm saying no decimals. It has to be a whole number. But you can choose to put how many ever decimal digits you want. Then I can say company and I can give the name of the company and their address. I can say type series A equity shares. I can say issue date and I can put today's date. Please remember, you can do whatever you want here. Within these curly brackets, you can create unlimited parameters, give it whatever name you want and feed whatever data you want into it. And when you run that here, it will run it and it will generate the transaction ID. Again, you may remember, on a blockchain, whenever a transaction goes through, a transaction ID has to be generated. If it is not generated, then something has gone wrong. So when you're preparing your code, always call back the transaction ID, because if it is not coming back to your application should immediately realize the transaction has not gone through, and it should then try to do it again. So transaction IDs are critical in blockchain. Now, when I run list assets, I can see this asset. So as you can notice here, the name is Alpha LLC Series A. It was issued in the transaction ID this. So from an auditing point of view, transaction IDs become critical. Then you can refer to this asset in two ways. One is by calling it Alpha LLC Service A, but because it has spaces in the middle, it will give you errors in your application. So in that scenario, use an asset ref. That is a number generated by the blockchain automatically. We don't do it, and it has got numbers with hyphens in the middle. So when you are plugging this into your application, please do not use the name field, use the asset ref field, because in the name field your customer may enter all sorts of weird things, but asset ref you can refer to because it will always be clearly readable. So for this particular thing, this is the asset number. Then we can see the open is false, which means you cannot issue any more units of this. Then we can see that no restrictions have been set. Now you all must be hearing about the word smart contracts. Well, these in Ethereum, you would call the parameters differently, but it is exactly the same thing. A smart contract for an asset basically sets all these things: the name, the kinds of permissions it has. In multi-chain, which is just like Bitcoin, the parameters are run in a different way. In Ethereum, it is run in a different way, but they stand for the same thing. What you call as a smart contract there is exactly this. Then we can see that, okay, this is all false. Then we can see the details. These are the three parameters we set up, and this is the issue quantity, and we have not subscribed to any data stream. Okay, I have just about 2 minutes to go, so I will quickly try to wrap up. So this is how we created an asset. Then I have created a second asset, in which case I have kept it as open. So here again, when I run it, I get my transaction ID, and here I can see that that particular asset is called Bitcoin wrapped token. And again, the same kind of information is here. The only difference is this is an open one. And before I conclude, I would like to say that in blockchain, we can also directly push data. I don't know if you have heard, but in the Bitcoin blockchain, people have even put love letters into it. Well, how do you do that? You do it like this. So you are using issue more from one address to another address, but a quantity of 0. So you're not actually issuing any currency, but you are embedding a message. So it is possible for someone to simply put a message into the blockchain. And that is one more reason why you should have a transaction fee. Because if you don't have a transaction fee, people can just start bombarding your blockchain with millions of data messages. So we can send data as well with multi-chain? Yes, absolutely. You can send data as well. That's how it looks. And then again, a transaction ID gets generated. And then when you run a command for that particular asset, you will see that one of the transactions for that asset will be the message that you have entered. Now we've run out of time, but later you can click here. So I have created this blockchain security controls. It's about a 60-70 page document, completely detailing how you can secure the blockchain. Hence the name blockchain security control. So please click on that link and download the document and go through it. Now, since my time is up, I won't be able to take any more questions. So I'll request, if you have questions, email them to me. I'm going to keep this IP address running till Sunday night. So if you want to try it out, please set up your node and then send me an email. I will immediately connect you to the blockchain, and then you can try running your commands. So great. It was great being connected to all of you. I hope you enjoyed the session. Thank you so much. Bye-bye. I think the admin will have to log me out. Yeah, hi.
Hi, sir. Do you hear me?
I can exit now. I mean, it's all done, right?
Yep. That was a very informative session from you, and I think lot many people got their doubts solved from you and might be practicing in the next upcoming days and might be sending you emails as well.
Sure, I look forward to
So
it.
thank you once again for joining us and being a speaker for our conference. Yep, that's it for the
Okay.
session. Thank you once again. Bye bye,
Okay.
sir.
Bye-bye. Bye.
All right, so we'll wait for the next speaker. Uh, we have Peter coming in a way just in 5-10 minutes. So we'll wait for him to join our session. Hey, Peter, can you hear me?
Yes, I can. Hello.
Hey, Peter, what's up? So I think it's very early morning for you, right? Where's the coffee?
Oh, I got my coffee ready to go.
Right. Yes. So everyone, can you kindly cheer for Peter? Just write Peter in the comments, and let's cheer for him.
Thank you. Shall I
All
get
right.
started? We're a few minutes early.
Yep. Just uh, changing the layout. Your screen is online and live, and I'm putting myself off.
Okay. Thank you so much. I'm very excited to be here. Yeah, it's 6 a.m. here in California. I got my coffee ready to go. So what we are going to talk about today is we'll look at the state of the blockchain security in the year 2021. We'll look back at the past year, we'll predict the future, or try to gain insights, the indicators that we saw in the past, and we'll talk about the different opportunities to build a stronger and more secure community and also a financial system. So with that, like the whole cryptocurrency industry reminds me of the gold rush in California that was happening in mid 19th century. If you're not familiar, gold was discovered in California around 1848, and people just rushed in after they heard the news. 300,000 people from all over the world just jumped on the ships, sailed over to San Francisco, that's my hometown, and went off digging. If you walk around San Francisco, you actually can see on the streets a whole bunch of signs basically saying like there's a ship that was abandoned and buried right underneath city streets. So cryptocurrency industry is very similar in that regard, where you have people abandoning their previous jobs, livelihoods, and all going all in into cryptocurrency trading, DeFi, investing, and so on. Now you can imagine that. So taking San Francisco as an example, uh, the town went from 200 population of 200 to 36,000 in just a few years. Not all the folks that moved to San Francisco were the nice, hardworking folks. It also, this whole rush attracted criminals and scammers. There was very little law enforcement at that time. So the gold rush era that you can read about is also marked by a lot of lawlessness. There were duels in the streets. People there people were going after each other. There was public hangings, jail breakouts, vigilantism because there was no police. So it got pretty wild. Blockchain security today is kind of like that, where there are very few companies, security companies, that can protect folks who are actually building and developing and trying to change the financial system. So this is something I hope that will change in the future, where we are going to have just as mature security ecosystem that we enjoy in web application security and other fields. In case we have not met, my name is Peter Kaczerginski, and I care about blockchain security for a variety of reasons. One, it is my full-time job, so I'm a blockchain security engineer at Coinbase, where I look at different blockchains and smart contracts, try to secure them, try to monitor to make sure that the exchange remains safe. I'm also personally vested in this field because I think there's a lot of benefit that can come out of this. There's a lot of things that the society and humanity as a whole can benefit from this from cryptocurrencies. So protecting it and making sure that the open financial system that we envision actually happens is my top priority. In the past, I've also worked as a malware reverse engineer, penetration tester at the Federal Reserve System. And I also publish the newsletter called Blockchain Threat Intelligence, which I'll discuss in a bit. So first, let's define the field. What is that? What is this blockchain security field? Well, it's a brand new security field. Its mission is to secure and defend the cryptocurrency ecosystem. And there's a lot of components. So we can talk about blockchain protocols, consensus mechanisms, smart contract security. Well, this is big this year. Key storage and exchange security practices. On the law enforcement side, we have blockchain investigations and many other topics. So if you want to visualize the whole field, you can see this interaction between exchanges who are storing assets for the users, exchanges relying on cold and hot storage to keep the funds safe. We have users who are on their own. They can interact directly with assets or DeFi, and they rely on the safety of wallets. Assets themselves, they have a variety of components. They interact with smart contracts, node software to get the latest state, and of course DeFi, which is which can interact with users directly, and it relies on smart contract infrastructure that it's built on. And now picture for a minute how all of this is getting attacked from all different directions. Exchanges are getting hacked, users are getting phished, DeFi applications, they are getting compromised assets, they rely on blockchains, which also have issues. So we'll take this graph and we'll take it apart slowly, piece by piece. This brings us to the theme for this presentation. If you're familiar with the movie The Good, the Bad, and the Ugly, this is a new frontier, and the frontier of cryptocurrency, and we'll explore the growing field of blockchain security by talking about the good that we have in this field, all the people who are building and creating new things. We'll talk about the bad, like all the incidents and all the hacks that are happening, and of course the ugly, who are the perpetrators behind those incidents. So with that, let's start with the bad. So let's first talk about all of the disasters, hacks that are happening on a daily basis. So for the last year, I tracked about $500 million worth of loss in a variety of incidents. The number actually is a lot larger. So if we consider things like Ponzi schemes, ransomware, cryptojacking, the amount is actually more in the billions. But I want to focus more on what makes blockchain security incidents unique, as opposed to criminals simply using cryptocurrencies in more traditional schemes. So the breakdown is as follows. So on the exchange side, we are at $310 billion lost. That's definitely an increase. We'll talk more about that. On the DeFi side, this came out of nowhere for 2020. We're at more than $230 billion lost in a variety of different incidents, hacks, scams, and so on. On the blockchain side, blockchain, individual, and wallets, they constitute only much smaller pieces. So that's basically how we're going to follow our discussion. Let's talk about exchange and crypto business incidents. So as I mentioned, $310 million were lost last year. The year started, if you saw my previous DEF CON talk, there were existing trends which held true for the rest of the year, and they appear to be holding this year as well. Attackers are going after PII. PII is personally identifiable information, so your email addresses, your home addresses, phone numbers, and so on. So after after 2020, we saw BlockFi, CoinCheck, BuyUcoin, CoinSquare, and others. They all reported a variety of PII being stolen. And then, of course, the whole point of hacks in many cases is just to get some kind of financial profit. So we have two themes here. On one side, we have external threats, which are Etherbase, Together, and a few other exchanges that had their hot wallets compromised. And the losses there were relatively small. So we're talking about $1 million to maybe up to 5.4 in Etherbase. And then we have a variety of insider threats. So we have Kasha Exchange, where employee laptop was not secured correctly. So we'll discuss that more in the threat actor description. Shapeshift had $1 million stolen as an insider threat. So the year was going pretty well. The exchange security looked pretty well until we had a few big ones. So one crypto business, Ledger, reported around mid-year that they had a compromise. They didn't fully say like how big it was, how bad it was. Only later we found out that more than a million emails and 292,000 detailed customer pieces of data were stolen across two separate incidents. So the Ledger database, we only found out about it because it was actually leaked on a hacker forum, and that basically started one of the largest phishing campaigns and later even physical attacks against cryptocurrency holders. Can you imagine what evildoers can do when they have hundreds of thousands of whole mailing addresses and phone numbers and full names for individuals who are known to be cryptocurrency holders? Not to be outdone, North Korean Lazarus Group managed to hack KU Coin Exchange and steal $281 million. Recall that out of $281 million, actually the large chunk of the total 310 million lost. What was interesting about this hack is that 84% of the 84% of the stolen funds were actually recovered. And that's a fascinating thing, because how could they do this? How did they recover it? Well, it turns out that the majority of stolen assets were smart contracts. And unlike a lot of blockchains, or most blockchains, as we'll discuss later, asset issuers have a lot of power in what they can do with them. So KU Coin was able to convince a lot of the asset issuers to basically either upgrade their contracts and specifically blacklist attackers' addresses and mint those funds to compensate KU Coin, or if smart contracts had specific functionality to blacklist addresses or confiscate funds, they were all able to cooperate with the exchange and recover and return those funds. So this is kind of unprecedented, right? What's the incentive model here? Are asset issuers really on the hook to compensate exchanges who were hacked? Is that a goodwill action, or is it contractual obligations? It's unclear, but it's fascinating to watch. On the other hand, and this is more unfortunate, so the incidents that we discussed so far were, they're all in the digital domain. Worst case, developers will lose sleep for the next few months. They will spend they'll drink a lot of coffee, they'll do a lot of investigation, forensic analysis. Flying Atom was different. Flying Atom is an exchange in Poland that had a physical incident. $120,000 were stolen after armed attackers broke into the physical building of the exchange, injured two employees, and I guess they figured that the exchange has some funds, which surprisingly did. It was storing gold on premises. Physical threat is something that is not often considered in exchange security, but it is part of the overall model, though. So let's gain some insights. Like what are the trends and things that we see here? Are exchanges getting more secure? Last time I gave the stock, yes, I was definitely saying that, yeah, they were getting secure. The number of incidents going down, monetary damage. Well, the number of incidents did go up. It practically doubled since 2019. Monetary damage, with a caveat that most of the damage was done by a single hack of KU Coin, it did go up. If not for this one incident, it would actually be improving, but the KU Coin hack was big. It is an interesting trend to see exchanges working with asset issuers to refund funds. It brings up interesting questions about liabilities. Attackers are getting more creative. A few of the hacks last year involved attackers not even going after infrastructure of the exchange itself, but they took over DNS panels on GoDaddy to just redirect users to some malicious website and collect their data. And of course, the trend continues that the attackers are going beyond just stealing hot wallets. They're very happy with just getting as much PII and maybe using them in phishing attacks later on. Last but not least, insider and physical threats are just as important to overall exchange security as securing their infrastructure and hot wallets and cold storage. So let's talk about the big one, DeFi. DeFi incidents last year constituted about 230 million a loss. Again, like looking at the first half of the year, we could immediately see, okay, this year is going to be pretty bad. Like immediately we had BZX got hacked a couple times. Uniswap had 300K drained, and on again. So you could kind of see that this is going to be the new trend. I did not expect to see what's going to come next. In the second half of the year, double the amount, double the number of incidents were getting hit one after another after another. So you could see, like I highlighted the month of November. It was just in a single month. I remember when I was writing a newsletter, every single day there was news of, okay, there's another project that got compromised. What is the bug? Reentrancy. You start seeing patterns evolve over and over. Weak Oracle attack. The numbers continued growing one after another. We started with a few 100,000 lost to millions and millions. So one particular month, it was, I'll just call it Bloody November. It was just, in a single month, 76 million were stolen, like with more than a dozen incidents. Every other day, there was something new. This year is not looking as well either. We're just a few months in. We're already $63 million lost in different hacks, and the patterns keep on repeating. So what are they? What are those incidents, and what do we keep seeing over and over again? Well, for one, I guess DeFi projects were not prepared to expand how they develop their software to new threats that appear. Like they needed to collect price data from somewhere. So they started implementing oracles. But if they implement it in an incorrect way, those price oracles could be manipulated. And that was the case with Warp Finance and Harvest Finance and others. And that would result in attackers being able to buy something for the cheap. Arbitrage and price slippage, saddle finance, hedging options, and others found opportunities to quickly extract value with flash loans, which I'll come back to in a sec. Composability attacks. There are some interactions which people just could not predict. So if you imagine that DeFi is all about the money Legos, it's very hard. The complexity of it becomes exponential when you start interacting with a different project and it exhibits some behavior which you could never even predict yet. So that was the case with Uniswap, IMBTC, where they didn't know, like, oh, wow, how is this token different? How could this cause issues? Logic errors, they mostly exhibit themselves as money printing bugs. So that was the case with 88MPH, Cover Protocol, Pickle, BZX, and so on. And then, of course, it's funny to call them traditional smart contract vulnerabilities because the whole field exists for just a few years. But reentrancy and bad math issues, they keep on popping up just as well. Last but not least, there's a common misconception that flash loans is a vulnerability. It's not really, it's just a feature, right? It allows attackers to make their hacks that much more powerful, that much more damaging by doing something that normally would be possible with if you're a whale and you had large amounts of assets. So it's just a feature. It's not a bug. On the other hand, on the more optimistic side, I guess, only half of the incidents that I tracked last year resulted in monetary loss. And the reason why is that a lot of the asset issuers, they were actually able to figure out that they had vulnerabilities through either themselves or they had third-party reports. They scrambled to shut down, upgrade, sometimes actually hack their own contracts with the vulnerabilities before someone else could, but they were able to recover. So white-hat hackers, this is just from last week. So there were 4 different four different vulnerabilities reported to these projects. So Primitive got a heads up from DDub and Immunify that they had a vulnerability. They quickly hacked their own contracts and recovered the funds. SamCZ Sun started looking into NFTs, and the big project Hashmask had a vulnerability that they patched. 4tube, similar. Dexter, that's a Dex on the Tezos platform, also had a vulnerability reported to them, and they had to hack themselves. So there's not everything is bad. Uh, Bug bounties work. So some insights. One, complex code interaction between DeFi components. They create these new classes of bugs, which are fascinating to watch. We're going to see more of them. So 230 million stolen though. That's if we look back at what was happening just this year. So this year, in just 2 months, we had $60 million lost. So if we extrapolate that, if this is going to be the trend, we're probably going to double that amount in 2021. Bug bounties work, responsible disclosure works, that needs to grow. And then it's going to be interesting to see more unique smart contracts getting attacked. So NFTs are probably next. We should be seeing more hacks there because more and more people are deploying those and making more complex interactions. So they're likely to get attacked as well. So if you think back to late 1990s, early 2000s web application security, we're kind of in the same state with DeFi security right now. Back then, there were no tools like Burp Proxy or methodologies like OWASP. There were very few web security shops or bug bounty programs. That was unheard of. So we're kind of in the same state, like it's just only the beginning of it. So we're likely going to see it evolve, and it's going to be painful, but we're going to learn on our mistakes. So this was an interesting article that I found the other day from CGI Security. It's an old school web or AppSec resource where they were drawing analogies of this field from 20 years ago. So we're basically in the year 2000 of DeFi security. Let's talk about blockchains. So everything that we discussed right now, DeFi and all of that, that still relies on layer one blockchains. So we're talking about Ethereum, Bitcoin, Tezos, and so on. $20 million were lost in a variety of different incidents on the blockchain space. So we have our usual suspects, 51% attacks. So Bitcoin Gold and Ethereum Classic, they were basically getting hacked over and over again. Ethereum Classic in particular, in a single month of August, they got attacked 3 different times. Bitcoin Gold was interesting in that a NiceHash miners, and NiceHash, if you're not familiar, you can rent hash power capacity to be able to profit. Some attackers use it to perform 51% attacks. So one of those miners notified Bitcoin Gold to tell them, hey, there's about to be an attack going against you, which allowed Bitcoin Gold to quickly create a checkpoint, which they secretly distributed among miners. So a checkpoint basically invalidates a single block or pins a single block hash to make sure that this is the state of truth. This essentially locked the attacker's chain out. So by the time that they announced it and released their secret chain, it was simply ignored. If you want to learn more about this, let me know. I can talk more about how 51% attacks work. On the Ethereum Classic side, it was just fascinating to see just how many blocks were orphaned. So we started with 29 block reorg in January. By August, we were looking at 7,000 plus block reorgs. At that time, it seemed absolutely massive. Like these are multiple days worth of blocks getting expunged. And that was fine until this year, last week, Verge 51% attack happened. And that amount went from 7,000 to 560,000. So this was 200 days worth of blockchain simply getting erased. The team was able to respond to it with the usual approach. So they created a hard fork, they put in a checkpoint, distributed, but it's not clear if there were any double spends. Most likely there were, and what the damage was. Another interesting blockchain network incident is the Firecoin, used to be called Zcoin. And it's not so much because of how large the reorg was. It was only 360 blocks were orphaned, or the amount double spent, but it's the ability by the blockchain to freeze or lock attackers' funds. This is interesting. Normally, blockchains do not have this capability. If you told someone like Bitcoin can freeze an account, that would raise hell. Not only that, Firecoin was also able to They started a voting system, and they voted in to compensate Binance that got double spent for that amount. So what they did is they once again created a hard fork where they allowed one single transaction to go through without verification. So you don't have to do minor checkpoints and all of that stuff. And they were able to get that money back and mint more for Binance. So it brings up, again, an interesting point where who's liable here? Technically, it is on FIRO that they were 51% attacked, but I guess it creates an interesting precedent for asset issuers, again, compensating exchanges for their losses. So if we were to get some insights so far, proof of work coins, if you can rent GPU hash power to mine proof of work coins, they will continue getting 51% attack. There's no going around getting ASICs and being the dominant asset within the ASIC class, within the hash class. Bitcoin Gold working with miners to secretly deploy checkpoints is a interesting pattern. Maybe there's more room for threat intelligence trying to detect 51% attacks before they even happen. The common approach to security is checkpoints and hard forks. That's basically happened in most of the major incidents. And will blockchains be liable to compensate exchanges that hacked? We'll see. Like, this is a new trend. So seeing a few questions come in. Are new blockchains more vulnerable to 51% attacks? It depends. Like, if they rely on proof of work chains and they chose a hashing algorithm, which is commonly used, or you can easily rent GPU capacity for it, yeah, probably are. Which is why a lot of newer blockchains, they go after proof of stake. Let's talk about some more interesting incidents. These go beyond this common pattern of, the rent hash power, 51% double spend, done, next. One that happened last year was Steemit. And this one was interesting because it's a proof of stake algorithm, and those are vulnerable too, but they're vulnerable not by someone aggregating or renting hash power capacity. They are vulnerable to folks that can accumulate a large amount of the assets so they can make staking decisions. In this case, multiple exchanges colluded to basically kick out all of the existing validator nodes and put in validators that they controlled. So this was first of a kind proof of stake attack. Ethereum, mempool manipulation, that was interesting in regards to that they weren't really targeting Ethereum as a coin itself. They were targeting MakerDAO. They were targeting higher level protocols. By causing congestion and manipulating mempool, they were able to issue a whole bunch of different liquidation transactions on the MakerDAO auctions for basically nothing. Bitcoin Cash ABC is unique. So if you're not familiar, Bitcoin Cash split off from Bitcoin, and then Bitcoin Cash itself split off into BSV, and then later on Bitcoin Cash ABC after they had disagreements. Well, someone was not too happy with that split, so they launched a griefing attack where they 51% attacked the coin, and they were not looking for any personal profit. They were basically trying to shut down the network, even at their personal loss. So that attack was happening for a few weeks until the attacker gave up. The last but not least is the Monero Sybil attack, where someone tried to basically de-anonymize the network. The attempt failed, but it's kind of interesting because the attack happened within months after US Treasury announced a bounty for any shop that can de-anonymize Monero, and a few of the blockchain analytics companies started publishing papers on exactly how to do that, or their approaches to it. So some insights on the blockchain incidents. The Steemit attack, shows us the first real example of proof of stake attacks and how it's likely going to play out in the future. So we're probably going to see exchanges. We're probably going to see whales collaborating together in order to target the network. It's actually getting more creative. So mempool manipulation. Not all attackers are financially motivated. Some people could be just angry or have some other agenda. And then Monero side, if this was indeed an attack performed as a demo or a research project that came out of the bounty that was put in by U.S. Treasury, this could probably be the first example of a state-sponsored attack against a blockchain. So food for thought there. Blockchain software incidents. So the total amount stolen as a result of someone targeting the underlying software operating all the blockchains is $6.7 million. So there were a variety of incidents that we saw on testnet. So people are catching the bugs early on. Filecoin and Solana had pretty nasty bugs that they caught early on. Tendermint just sees denial of service bugs pop up every few months. The two on the right, they're probably more concerning. So Ethereum parity and Ethereum get vulnerabilities. These are both very well-established projects. So on the parity side, a denial of service bug knocked out about 13% of the network later last year. And on the get side, we had an older version, which was silently patched but not announced to that there was a vulnerability there, also ended up knocking out large portions of the network, especially like major projects which were running older vulnerable versions like Infura, for which a lot of the projects rely on. So this is an interesting lesson of should critical vulnerabilities be silently patched? What if someone discovers them? Should you approach it in more traditional sense where you announce it to the whole world and tell people that you need to patch as quickly as possible? So there's some projects that prefer to do that versus silently patching and then waiting for enough nodes. But there are different scenarios that can play out there as well. On the wallet incident side, we had a few. Monero wallet had one where they were not parsing some specially crafted Coinbase transaction correctly. Lightning Network is still very much in alpha. We see like there's just a stream of vulnerabilities that get published again and again. Amazing find by Open Zeppelin on Argent Wallet, where they had the wallet takeover vulnerability. And then Ledger Live and a few other wallets, they were not processing RBF transactions properly. So RBF is replaced by fee. So basically you can send a transaction and then you can send another transaction with higher fees, so it will replace a previous one. Well, some wallets, they did not process this correctly, so they would show a balance of the initial transaction. So there could be some social engineering attacks there. And then we have supply chain attacks. So this is the real threat to all the node and wallet software. To wallet software, we had the Trinity wallet, and that one was backdoored through a third-party dependency. $1.6 million were stolen. Even worse, it basically shut down the whole network, IOTA, until they figured out like what was actually happening, like how are the attackers stealing the funds, until they narrowed it down, like, oh, okay, so they compromised the actual wallet. And then we had Ravencoin, where someone created an anonymous GitHub account, snuck in a tiny little PR into the code base, which appeared benign. The PR got included in the main code base node software code base, and it basically introduced an inflation bug. Someone could mint arbitrary amounts of Ravencoin. And that was going on basically for 6 months until someone was developing a blockchain explorer, I believe, and they saw like there's some irregularities here. When they started investigating, they saw like, oh, okay, they stole $5 million over the last 6 months. They've been minting that money and selling them off on exchanges. So they had to go with a very quick emergency patch there. So supply chain attacks, especially, we saw what was happening in more traditional security, where basically everyone got hacked as a result of the was it SolarWinds hack. So it's going to be just as applicable to blockchain security. Silently patching vulnerabilities can backfire. So there's some project like Ethereum, Bitcoin, definitely they tend to do that for critical flaws. What keeps me up at night though is node flaws are still very rare. So if we look at more traditional software, we look at maybe not web browsers, which are getting attacked constantly, but something we consider to be very secure. So you take an operating system like OpenBSD or mobile software like iOS, some super secure web servers, the Nginx or whatever. These get hacked well, not constantly, but they do get discovered some critical bugs on a fairly regular basis. So we can find the remote code execution. Why are we not seeing similar things in node software? I imagine that there are vulnerabilities like that. They're sitting there. They're just not being discovered or exploited just yet. And the reason for it, I can only guess, is that I'm not sure if there are not enough eyes or interest in pursuing that. People would much rather maybe set up new NFT tokens and profit there, as opposed to writing ODAs for nodes. Let's look at users. So user incidents last year resulted in a loss of $8 million, or billions if you start considering all the scams and Ponzi schemes. So, but we'll focus on just the technical side of it. We're not going to talk about scammers just using cryptocurrencies in their usual schemes. So Ponzi schemes, just in general, like we're talking about billions of losses. So previously I talked about WO token scam, that was $1 billion. Right now there's Mirror Trading International out of South Africa, that's almost $600 million. Before it was Plus Token, that was in the billions, and BitConnect, and on and on. These tend to pop up constantly and result in billions of dollars worth of loss to users. Well, the first scam that I'm going to talk about are crypto giveaway scams. And one second. And that's basically, people are taking over YouTube accounts or taking out ads on Google or tweeting, usually by Elon Musk or SpaceX or Bill Gates or many others. And basically, it's a scheme where they ask you for, send me some money and we'll double it for you. So this has been going on for a while until the big one hit. That was the Twitter hack back in July, where the attackers basically took over hundreds of accounts belonging to first exchanges, then celebrities, corporate accounts. We had Warren Buffett tweeting and saying that, you should send money to this address. The irony of it all was that the total profits were only $120,000, but the damage that was done to Twitter and the overall ecosystem was much larger. It could have been much worse, obviously. On the DeFi scam space, let's zero in on this a little bit. One, there's some more technical targets, like you have people creating basically a copy of MakerDAO websites and completely hooked up with smart contracts, and people were getting phished, like, hey, like, interacted with this website, it looks just like legitimate MakerDAO, except the contracts that you're interacting are completely different, and you're basically giving all your money to the scammers. Then you had people deploying contracts with hidden backdoors inside them. So that was the Chicken Finance, Axion, Compounder. Others like Unicats, they basically built in an infinite allow back to the scammers. So once enough funds were put into the contract, they basically sweeped it all. And then you have more traditional exit scams and fake tokens. So on the exit scams, there was, the infamous incident with Chef Nomi, who ran off from the project. It goes a little bit deeper than that, so I invite you to read my write-up on it. Blue Kirby with the off-blue scam. And then you have, if you're ever interacting with Uniswap, watch out for the multitude of fake LP pairs. So people are just simply setting up token pairs, which designed to replicate something real, but it's just some other token that they generated, so it's fake. I'll go through questions towards the end just to make sure I have enough time to cover the material. But on more dangerous user incidents, I previously mentioned the Ledger database leak. Well, that one got a lot worse after all of that data was leaked on the hacker forum. So what this resulted in is, one, just phishing emails, which quickly progressed to phishing text messages, which quickly progressed to people basically getting phone calls demanding ransom from random people. So you can imagine a database of 200,000 or more people's addresses. it can get physical there. So that was one of the worst incidents last year. Backdoored wallets, so Trust Wallets and many other fakes keep showing up on Google Play Store. I'll come back to this one with Harry's epic hack to get the funds back. And the really big one is the Nexus Mutual founder hack, where $8 million were stolen, where a founder was specifically targeted to steal his funds. Normally, attackers deploy wider nets to capture their victims, but in this case, they went for a specific computer, they targeted it, they installed malware on it, they installed backdoored wallet software, and once the user was interacting with the chain, they were able to sweep all the funds. So some insights on user security. We are probably going to see more highly targeted, sophisticated attacks on high net worth individuals, especially now that there's this large database of people who own cryptocurrencies. Technical and non-technical scams are definitely on the rise. PII leaks that we saw from Ledger and many other incidents, they are powering larger and larger phishing campaigns. And these MLM schemes, they'll keep on popping, but we'll just keep seeing them again and again. Okay, so let's talk about the ugly. The ugly are the perpetrators behind all these attacks. Let's discuss who is actually doing this. Like, who are the folks and organizations behind all of this? So if we're talking about bad actors, we can roughly split them up into the following groups. On the right, we have our APTs, so advanced persistent threats. These are the folks that are dedicated. It's probably their full-time jobs doing those things. We have our state-sponsored attackers. We have our financial and ransomware groups. And interestingly, last year, we start seeing dedicated APTs, which are focusing on cryptocurrencies. On the left, we see more individual attackers. We have our black hats, who are just usually individuals, high skills individuals trying to make a profit. We have our script kiddies, usually going after SIM swaps and more low-tech attacks. And of course, the insider threat. So let's break it down. On the nation state side, so these are government-sponsored groups. We have our Lazarus, which is a North Korean group, APT 38. And these have been implicated in one exchange hack after another. So KU Coin that I discussed earlier today was one of those examples. There was actually recently a United States Department of Justice indictment issued for 3 North Korean individuals, which documents in depth all the different schemes that they are involved in. On the other hand, we have Ocean Lotus, which is the Vietnamese-based. Sorry, could someone confirm in the chat if the presentation is now synced up? Okay, I'll keep going, but let me know if I need to restart anything. So we have Ocean Lotus and Wicked Panda. These are Vietnamese and Chinese APT groups, but these are they don't have the same tactics as Lazarus because they are usually just a little bit more subtle. They usually go after infecting machines with malware and just mining cryptocurrency. On the criminal side, for the most part, we have groups which are going after highly profitable ransomware campaigns. So you have your Maze, Netwalker, TA505, Revel, and so on. So last year, according to Chainalysis, they made about $350 million. So it's fairly profitable enterprise for them. And then, of course, we have the very first dedicated APT called CryptoCore. So if you want to read a Clear Sky report on them, these are the guys that are just razor focused on just targeting cryptocurrency exchanges or related schemes. So we have one of those now. And then we have a script kiddie threat. So the Twitter hack, like they were basically caught within days of the attack. So there was part of the OG users group. And they're basically folks in their early 20s, teens that are just doing silly things and getting caught and going to jail. SIM swapping groups. Then, of course, we have insider threats. So we have an individual that was caught stealing $1 million from Shapeshift. It was one of the employees. Shapeshift is actually kind of interesting. I think they had one or two other insider threat incidents where they hire people who are kind of malicious and end up costing them. Alpha Homora, so Alpha Finance hack, is suspected to be perpetrated by insider because of just the amount of knowledge that was necessary to execute the hack so quickly. The other insider threat is not exactly where so there's someone malicious who actively wants to hurt the company. In the case of Kasha, it was pure negligence. The employee was running basically running some operation of the exchange on his personal machine, which was unprotected, got malware on it, and lost all the funds. So it's a different type of insider threat, but insider threat nonetheless. And now the big question is, but who are all those DeFi black hats? Well, we don't know. The closest that we ever got to catching a DeFi hacker was in the DForce hack, where attacker managed to leak their address after they retrieved some content, not from IPFS, but from a web resource directly. After they leaked that, they got their IP address. They got that they were using a Mac computer with EN/US language, system language. So they ended up quickly returning all the stolen funds, and I guess the investigation stopped there. But that was the closest that we got. Then you have a lot of hackers. There's the new trend where they basically send messages to their victims, like on the blockchain in the just a data payload field. Things like, do you really flash loan in Value DeFi? Just kind of mocking the project. Covered protocol. There was not a black hat. They returned all the funds, but again, this like with the messages. Next time, take care of your own shit. So if we start thinking about like who are these people, some things that we can notice. One is they all have pretty bad OPSEC. You don't see Lazarus messaging their victims, mocking them. They'll just take the money and they'll be too busy washing them and so on. Two, just the skill set involved in executing those DeFi hacks. If these were just criminal groups like we saw before that are currently involved in ransomware, there's a lot easier ways to make money on DeFi. They could create scams. They could create fake LP tokens. Basically, you don't need to go to this level to start making money here. So more likely than not, based on the bad OPSEC, based on high skill set required, these are probably the same high-skilled individuals who are writing those DeFi projects in the first place, who decided for one reason or another to just cross the line and make money with a criminal intent. So the presentation would not be complete without talking about the good folks. These are the people that make this field so exciting and inspiring to write about. That's what keeps it going. So the folks that are the good guys out there, one is, if you saw in the DeFi space, I mentioned that about half of the incidents were prevented because white hats were reporting those vulnerabilities ahead of time. They were actively seeking them out and helping developers patch them. So one such white hat is Sam CZ-Sun, who helped 18 different projects last year to get patched, helped them fix vulnerabilities. In one incident, he helped them execute the hack to save $9.6 million. He also shares his knowledge with the industry by publishing blogs. He recently organized Paradigm CTF, which I highly recommend if you want to go over solutions and play yourself. To share, all of this is used to uplift the industry and learn more about DeFi security. So applause to him. Harry Danley is another sheriff in the lawless crypto frontier. So Harry Danley, like if you look at his Twitter and blog posts, he's been on this for years. He's been helping shut down phishing and malware campaigns one after another. It's kind of a thankless job. Like the second you knock them out, they pop up in a new place. Well, this time in 2020, Harry kind of took things into his own hands, where he saw that the phishers who were running the fake trust wallet scam, they were not operating the infrastructure well enough, and they were leaking all of the private keys that they stole from others. So he was able to scrape off the list of all the different private keys, steal the money from the hackers, and then return them to their rightful users. So same story happened with fake Uniswap and Balancer phishing campaigns, where he was able to save another $10,000 from the bad guys. Harry also runs a bunch of projects like Crypto Phishing Bot, Crypto Scam DB. All of them are used by the community in order to help detect scams and phishing attacks. Sometimes it requires a whole team to make impact on this field. So there are a lot of teams out there, like Open Zeppelin. They're publishing their contracts database, which are basically the de facto way to write smart contracts. Trail of Bits, Peck Shield, publishing analysis. One such team which made amazing contribution last year is Consensus Diligence, which published just so many amazing tools free of charge to the community: Scribble, T-Time, Legions, blockchain security database, and just a barrage of super useful VS Code extensions if you're a smart code auditor. So check them out. There are many more heroes, and you know who you are. And I proudly write about you, and it's a privilege to write about you and your stories and your struggles in my newsletter. And we're all in this together. We're all building this new frontier, and there are it will take thousands of developers, security engineers, entrepreneurs to be able to secure this field. Blockchain security is still very young and barely explored, just like the cryptocurrency ecosystem is trying to protect in the first place. So if you're looking to contribute, imagine there are a few things that you can do. One is we're severely lacking in guidelines, testing methodology, and tools. So pick your choice. So if you want to write tools to secure standalone blockchains, fuzzers, look at node configuration operation. If you have cryptography background, you can try to lock down the whole hot and cold storage, key management protocols. There's a lot. If you're more with the investigator side, you can dive into blockchain forensics and try to hunt down the bad guys, and so on. If you would like to share educational resources, organize CTF competitions, trainings, and if you just want to go full-time into this field, there are more and more places where you can become a full-time security professional looking at blockchain security issues. Try to explore different bug bounties out there, or start your consulting company. There's definitely a need for that. Some things to get started. I would recommend, selfishly, look at my newsletter. I try to outline all the new resources as they keep on popping up, and on a weekly basis, there's a lot. There's another project that I started recently called Open BlockSec, where blockchain threat intelligence is more, it changes constantly. Open BlockSec aims to create curated lists where I document just really solid resources that you can reference any given time. So for now, I just have one resource that I made public, which is just a list of all the capture the flag competitions and all the solutions that I could find as well. But in the future, I'm adding like just high quality talks, resources, and so on. So that's all, folks. Consider joining the good fight. Become a security engineer. If you have a background in web AppSec and you're just sick of looking for XSS and SQL injection vulns over and over again, dive into DeFi, dive into BlockSec. There's just untapped, unexplored field for you to look at. If you're an investigator and you like catching fraudsters, consider blockchain forensic analysis. If you're just a developer and you're looking for a new project, this is the field for you. Thank you. And now I'll scroll through the questions and see if I can catch up quickly. Or feel free to post questions in the chat and I'll respond to them live.
Okay, so one question is from someone is asking, can you please tell practical how Ponzi scam works so we improve our securities?
How Ponzi scams are what?
How Ponzi scam works so we improve our securities?
Well, Ponzi scams, they go after the human element, right? They explore the human security. So I think education is one, teaching people that like there's no such thing as free lunch, even though it seems like that sometimes in the last few months. Just education, knowing how to rate and distinguish legitimate projects from illegitimate ones. So that's maybe some kind of like, there are a few projects like DeFi Safety. They try to basically outline, rate different projects, saying like, hey, this is probably safe, this is probably a scam. So we probably need that for a lot more different projects out there. Any other questions?
I
Okay,
think we
well,
don't have questions here. I think this one already has been answered. I will just repeat it again. It's like, how does reversing transactions affect the trust in immutability of blockchain?
well, I mean, the only way to, I guess, the approach to reversing transactions, and that was actively discussed in the Binance hack a few years ago. If you actively collaborate with miners, you would be able to override some blocks in the past. But that's highly frowned upon proposition, because the whole concept of blockchains and decentralized ledgers is that like we shouldn't be doing stuff like that just because it's possible. And I discussed one coin that did that. They froze an account. They forced a transaction to compensate. So it's possible. 51% attacks are what can be used for that, but it's definitely not something that should be done or taken lightly, because it undermines the whole foundation behind this field.
Okay, people are asking for your social medias to connect you with.
Sure. I guess if you just, the best one would be my Twitter. If you want to reach out, let me see. I think I have it on one of the slides. Let's see if I can find it. Yeah, you're welcome to contact me on Twitter. It's just _iFelix. Career development tips. Try learning, try playing competitions like Ethernaut or Paradigm CTF that I mentioned. There's a huge shortage of professionals. If you want to pursue this field, and you should, it's a lot of fun, and there's just high demand for people who are knowledgeable about this, because we're all still just learning. So it's good to get in now and learn together as we all do. Just read a lot, read the newsletter, participate in competitions, and just be on the lookout. Unfortunately, there's no like solid book that you can buy that will give you everything you need to know about blockchain security. So you can start with just the basics, get your mastering Bitcoin, mastering Ethereum, and just go from there. Okay, well, folks, feel free to reach out. I'm happy to talk with you about blockchain security and other career development and other tips. And super excited about the conference. This is first of a kind, dedicated blockchain security conference. Excited to see more of us. Thank you.
Hey, Vida, can you hear me? Yep.
Yep.
I just want to thank you for waking so early for us and sharing your beautiful knowledge with us. We are all were very excited for this session, and I hope everyone learns a lot from you and probably following you on your social media and asking a lot more questions. And just reach out to Peter and just throw all your questions or doubts, where you want to start. Peter definitely going to help you out. Just thank you once again, Peter. It was a wonderful session. See ya. Bye
Thank
bye.
you. Bye.
Okay, so we'll wait for Josh from Chain Toots. He will be joining us within like 5 10 minutes. So we'll wait for him to join our session. Hey Josh, can you hear me?
Yeah, I can. Do
Yeah.
you see my
How's you,
slide?
Josh?
Doing great. I'm excited to be here.
Yep, same here for us. We all are excited to listen to you and your session, and I hope everyone is doing good and pretty excited as well, right? So I'm gonna share your screen on air. Now you're on air, and I'm gonna put myself on.
Ready to go then? All right. So first, I really want to thank you all for having me. I'm excited to be here. Um, it's awesome that there's this blockchain security conference going on, and you guys are doing great work with this. So um, what we're going to be talking about today is talking to your users about cryptocurrency security. I think this is an important topic that maybe gets missed sometimes. And, I want to really explain from sort of a tech educator perspective why it's so important to talk to your users about security and give you some new ideas about how to think about that. A little background on me. I'm a software engineer at Microsoft in Pittsburgh. So my day job, I don't work on cryptocurrencies. I'm sort of a systems and back end developer. And of course, the work that I do with Chain Toots is not representative of my employer. And I am a tech educator at my personal project that I call Chain Toots. And my mission is really just to build free and open source technical education. So I'm trying to help people around the world from all walks of life understand this really interesting and empowering technology, especially cryptocurrencies, blockchains, and digital security topics, even like passwords and two-factor auth, and really how to keep yourself safe online, especially interacting with this new cryptocurrency space. Before I get into what we're going to talk about specifically today, I'm going to talk about, a reminder of what the core of crypto ownership is, and that's private keys. So we call a cryptocurrency private key store a wallet. That's the industry terminology that we use. And it's absolutely critical that wallets with our private keys in them are both securely generated. So the keys themselves are actually generated in a secure manner and securely stored for the long term. Users these keys are what gives you full and utter access to spend and transfer cryptocurrency, all of your money. There's differing what I would describe as classes of wallets, all with differing threats that you have to understand and address when we're talking about security. So what are we actually going to talk about today? I'm really going to give kind of a broad overview of understanding wallets and the threats that specific classes of wallets face, and some of the common vulnerabilities and attack vectors that are out there. A lot of this that you're going to hear from me today is probably not going to be news to you as technical and security professionals, right? I'm not here to share new specific vulnerabilities or issues. What I really want to talk about is new perspectives on how to understand wallet security and present this to your users. So I'm really here to talk about security education, because I think we, as the technical builders in the space, have a duty to educate our users about security and how to keep themselves safe when interacting with this technology. Just like if you're a web application owner, you should, enforce strong passwords and two-factor authentication and those sorts of things. I think this is a topic that sometimes gets glanced over in the space because, it is sort of this very young technology. And I think some of us that are technical folks have a mentality that users should just get down to it and understand it and be their own bank. And if they screw up, woe on them. But, with the great power of being your own bank comes a great responsibility to understand your own safety and security. And so I really want to focus on presenting security information to people from differing backgrounds. So what I'm going to discuss is a couple broad classes of wallets and a sort of broad security overview of these different types of wallets. We're going to talk about some common cryptocurrency threats, and we're going to end with some security bullet points that you can give to your users, give to your clients, give to anybody that's interacting with this space and in your applications that you're building. So in terms of wallet classes or wallet categories, whatever sort of terminology you would like to use, perhaps even wallet types, there's kind of a sliding scale from generally the most secure types of wallets to generally the least secure. Offline wallets are definitely the top when it comes to long-term storage security and safety. Offline wallets being things like hardware wallets primarily are sort of the gold standard and the modern standard, but this also could include offline generated single key pairs. I'm going to get into a little bit later why single key pair is kind of fallen out of favor. But generally when we're talking about offline wallets and cold storage, we're talking about hardware wallets. The next class of wallets, and I should say the next broad class of wallets, is online storage. So wallets that are stored on a device that is generally connected to a network. At the top of this list in terms of security, and this may actually seem surprising, is really mobile wallets. So wallets that are installed and run on iOS or Android. And the reason that professionals like Andreas Antonopoulos and some security professionals and I say mobile wallets are preferable in the online space is because the operating system on your mobile device is going to be locked down a bit more than the operating system that is on your desktop, for example. And we'll get into that in a little bit more. The next broad class is online desktop wallets. So this is something like a Coinomi wallet or Electrum or Electron Cash that you install on a desktop device like a laptop, computer desktop, etc. And really the least secure and I would say most discouraged for non-custodial, so exchange type of service is online web wallets. So this is something like the blockchain.com wallet is by far the most popular example. And there's quite a few reasons why this is generally not so preferred. Now, there's sort of a special case, and it's a broad and important special case, and that's exchanges, custodial storage, where the user is not given any private keys to store and own their own cryptocurrency. But it's those private keys for that cryptocurrency are stored with a custodian. So prominent examples would be Coinbase, Binance, Gemini. It's kind of a special case for a couple of reasons, and that's because we're not talking about the users being responsible for their own money. We're talking about a custodian, and then we have to talk about the security and hygiene of how the user logs into that custodian, along with the custodian storage practices themselves. Broadly speaking, offline storage is going to be better and more secure for the long term than online storage. So if you're storing large amounts of money, when you're talking about savings and especially money that you're not going to interact with for some period of time, offline cold storage is going to be better than online storage. Specialized hardware is better than general purpose. And what I mean by this is something like a hardware wallet. So a device that has specialized cryptographic firmware loaded onto it, I think is in general going to be better in terms of long-term security of those private keys than a general purpose network device like a phone or a laptop. In general, in the cryptocurrency space, we really do prefer self-custody to an exchange. The whole sort of idea with Bitcoin, with Litecoin, with Bitcoin Cash or Ethereum is you get to be your own bank. So you get to hold your own keys, and that means you are truly holding ownership over your own money. I say this with a caveat. The user needs to be prepared for this, right? Most of us are kind of used to custodial money, right? A lot of us probably have bank accounts. Maybe you don't. Maybe you live in more of a cash-based sort of society where you're at. Some folks in the world don't have access to traditional banking. But in general, we're sort of used to credit cards. We're used to debit cards, bank accounts, and custody. We're used to kind of having somebody that can bail us out if we get hacked, right? If my credit card gets hacked, my number gets out there, I'm not responsible for those charges. It doesn't work that way with Bitcoin. If I make a mistake and lose money, there is no one there to rescue me. And so, there should be kind of an expectation that users are prepared for this before they move to self-custody. This is perhaps a controversial opinion in the crypto space, but I think if you're talking about an introductory amount of money, you're just getting your feet wet in cryptocurrency for the first time, and you are not a technical person, it's probably okay to keep a little bit of your money on a reputable exchange, because you may be tuned into password security and two-factor security more than you are private key storage for the time being. This will give you some time to learn. So overall, in general, the amount of money that we're talking about is going to dictate the level of security needed, right? The amount of security that you need for your spending money is different than the amount of security you need for your life savings of your Bitcoin. So let's talk offline wallets. I think users should always be highly encouraged to use hardware wallets. These are great and very well audited devices. So all key generation and storage is done completely offline on specialized hardware. Examples of this include the Trezor, the Ledger, Keep Key, and there's some other ones out there, but those are kind of the most well-known and most well vetted. This is done on specialized hardware that has firmware that is specifically for Bitcoin cryptography, right? These are microcontroller devices, and they're programmed to do one single thing: Bitcoin cryptography, Ethereum cryptography. So what this does in terms of security is it greatly lowers the attack surface for key theft. No one can watch the key generation or signatures in some way that might cause a problem for key leakage. Someone can't phone home with stolen keys like they could on your laptop if there's some kind of malware. And these devices generally don't run general purpose malware. Their firmware is explicitly designed that when you plug that device into a computer, the only data that it allows you to send to itself is the information that you would need to generate a signature for a transaction to send money, right? It doesn't have this ability to run a very general purpose malware like a laptop does. So I actually made a sort of demo proof of concept of my very own hardware wallet called MicroBitAdder, UBitAdder. This was a demo proof of concept that currently only does single key pairs, but it was kind of a demonstration that I've talked about at I had a chance to talk about it at DEF CON and some other talks. This is something that can be done with open hardware, open software, and it's a really neat and interesting way to generate keys and store keys. My particular demo only generates keys and presents them to the user in an encoded format, so you could write them down and store it offline. General availability hardware devices like the Keep Key or Trezor, they give you a seed, and then they also store the keys encrypted and can do transaction signatures and that sort of thing. Now, for online use, we should encourage mobile applications over desktop or web wallets, I think. So this is for your spending money. Mobile devices have a more locked down operating system. Now, I'm not in any way saying that this is foolproof. I mean, of course, there could be a lot of issues with something like a mobile device, and they do have vulnerabilities. But in general, an Android device or an iOS device has a more lockdown system, more safeguards in place. Most users go through app stores, right? So, most users, if they're careful or not, it's not as easy to download a malicious application that might try to get at your keys or ask you to sign a false transaction. So I like to use Bitcoin.com, for example, for Bitcoin Cash and Bitcoin. Coinomi is another one that I use. I don't, have any relationship with these companies. They're just ones that I've used that I've found to be usable and, have some decent security practices. So in general, when we're talking about your spending cash, to pay your phone bill, to buy a book, to buy some jujitsu gear, things that I like to buy, right? You can use a mobile wallet for that purpose. Now, let's talk about online wallets for desktop. These can have some issues. And the primary issues with this sort of wallet is they present a very high attack surface. There's malware threats. So, there's issues with people accidentally downloading malware onto their laptop, which can cause all sorts of problems when you're interacting with cryptocurrencies. You could have key leakage or theft of your keys that somebody could find out how to get at unencrypted keys potentially and send them off to an attacker. You have phishing attacks. Now, this is not something that's necessarily prevented by using a mobile or hardware wallet, but if you're commonly interacting with a desktop wallet, phishing attacks are issues. I'm going to talk a little bit about that later in Let's Talk Threats. And of course, bad passwords and password reuse. There's a whole host of issues and a whole host of hacks that have happened for people that, they reused a password all over the place. That password got leaked and cracked as part of a password dump data set. And attackers used that email and password to log into their blockchain.com wallets, log into their email to verify and wipe them clean. These are real things that have happened, and they're very scary when you talk about online wallets and desktop wallets. It just provides a much broader surface for all kinds of different vulnerabilities. I'm certainly not giving a comprehensive list of issues, and I don't know a comprehensive list of potential issues. But in general, the difference between a web wallet and a hardware wallet is the online wallet has a lot broader class of vulnerabilities that can happen with it and cause issues for your users. And again, exchanges are a special case because you're not being your own bank when you use an exchange. You are holding keys yourself. So in that case, your security is only as good as two very important things. The first thing is your security is only as good as their security. And that's a very big target. So this is not something to ignore or brush over, right? You really want to pick a good exchange if you are going to store money on an exchange. Like use a Coinbase, use a Binance, use an exchange that that hires some of the best security experts in the world and takes their security really, really seriously over a small startup. And I hate to say that because I think startups are great, right? But the security of the exchange itself is a really, really huge target. Now, the second very important target that falls on the users is your security is only as good as your password and two-factor hygiene. So if you're storing money on an exchange, you should absolutely make sure that you have a very long, strong passphrase that is unique to that website. And you should use app or hardware-based, like a YubiKey, two-factor authentication. SMS text message-based 2FA is not acceptable for this purpose. And we'll talk a little bit more about that as well. So let's get to the extra fun part. Let's talk threats, right? Let's talk some examples of threats that users are facing when it comes to their cryptocurrencies. Malware threats are a big one. And this primarily affects desktop, web, and mobile. Because again, this is sort of the broadest target for attackers, right? To try and specifically attack a user's offline hardware wallet is a much bigger task than it is to create a very broad, malware attack that you can potentially get to affect a lot of people. Address jacking, address swapping is one of these examples. I actually coded up a demo of this address swapping malware, and I call it AdderJack. So if you go to my YouTube channel, the ChainedTools channel, and my GitHub, I have a very simple demo written in C#.net of an address swapping malware. You can see on the slides a static example of this. What happens with this class of malware is when somebody copies an address into their copy-paste buffer, so they Control-C or right-click and copy a Bitcoin address. If this malware is lurking on their system, it can detect the format of a Bitcoin address using a regular expression. And when it detects that address, it replaces the intended address that's in the copy-paste buffer with an attacker's address instead. So in this example, I tried to copy the address starting with 1BRL, and my little demo detected that a Bitcoin address was in the copy-paste buffer and replaced it with one fake don't send invalid. So this is a real threat that has happened to people. I've had people reach out to me via my project that lost money this way. Their coins, they copied an address, they pasted the address and didn't double, triple check it. And what they did is when they went to send that transaction, that money got sent off to an attacker's wallet instead. So, I have this educational demo that you can check out, but I'm sure there's, real samples of this out there as well. I mean, this is a real threat that's happened. And it's kind of scary if you think about it, right? A lot of us kind of blindly trust our copy paste buffer, but you shouldn't do that. You should really ensure that when you go to send money, you double, triple check your addresses. Fake wallet software is a big one. So the Electrum phishing attack is a primary example of this. Electrum had a whole issue with there was sort of an injection attack that tricked users via one of their sort of updates, update notifications into installing a fake version of the Electrum software. And so when that fake software got installed, then when users would log into their wallet, it would steal their keys and send the money off to attackers. I'm not super well versed in that particular attack, but I know it caused kind of a big issue for a lot of users. And of course, there's sort of a whole class of malware that's theoretical and real. That's somebody could just steal your keys, right? If you have a desktop or mobile wallet and those keys aren't stored properly, maybe they're not properly encrypted with a strong passphrase, of course you're running a general purpose device. So someone could write malware that looks for wallet.dat, looks for the sort of signature of 12 to 24 seed words, even if you're putting your seed words somewhere unencrypted and use that to steal funds. Another very common threat, of course, is bad password and two-factor hygiene, right? This is something that doesn't just affect cryptocurrency, of course. This is something that affects all kinds of online accounts. Frankly, most people don't take their password security seriously enough. And this is something I always try to nag my friends and family about, is to use strong passphrases, use unique passphrases. Most people, unfortunately, reuse their passwords. So, Google and Facebook and Coinbase and Binance have good security over their password databases, surely. But the problem is, if you reuse your password for those accounts on some, one-off Etsy website or something that doesn't have very good security, and that gets leaked in an attack, now attackers have your password, right? With Hashcat and John the Ripper and all kind of modern password cracking tools, the passwords that most people use are fairly easy to crack and to find. And then attackers will use that email, use that password combination to try exchanges like Coinbase, to try web wallets like blockchain.info. And that can be used to completely wipe people out. It's a very scary and real class of attack. The other one that's important to talk about is SIM swapping. Don't use SMS text message-based two-factor authentication for exchange accounts or for web wallets. Just don't. People with high net worths that are involved in the crypto space have absolutely been targeted by this type of attack in the past. If attackers know that they have your phone number, if they can get your phone number and they know that you're on an exchange or something like that, they will try to call up AT&T or Verizon or Sprint and get the phone number transferred into their hands so they can reset access to the account using the SMS two-factor, as a reset or something like that. I know people in my network that have lost tons of cryptocurrency in that way. So instead, we should use the app-based, like TOTP is kind of the most common standard for that. It's a time-based one-time password. That's usually what you have when you use Microsoft Authenticator or Duo or Google Authenticator. Even better yet, get people to buy YubiKeys, right? A YubiKey hardware token is even better. And that's a lot better than what most people do, which is skip two-factor entirely. I think that two-factor is something that should be enforced, or just completely required for any kind of cryptocurrency-related web application or exchange, because protecting users is extremely important, and two-factor is very, very important for keeping them protected against password leaks and that sort of thing. Most people don't use long or higher entropy passphrases. I did a tutorial on this recently about password security, right? Length is, generally speaking, much, much more important than complexity. So we've been kind of taught that, if you have an 8-character password with a bunch of wingdings in it, at an exclamation point and parenthesis, that's going to save your password. And the reality is modern password cracking will eat through that in minutes to seconds in most cases. So length dramatically increases the math, right? If you go from an 8-character password to a 12-character password, or 14 or 16, when you talk about brute forcing that character space, it goes from minutes to hundreds of years to thousands of years to millions of years, depending on how long you go. Long passphrases that are sentences are better, and better yet, encourage people to use a password manager, a secure encrypted store of passwords. So they can generate one very long, very secure, and unbrute forceable passphrase for the password manager, and then everything else can simply be 20-character completely random passwords generated by the manager and autofilled. So like my passwords, I don't know any of my passwords other than my password manager and encryption passphrases. Everything else is random and stored in my password manager. And that makes life a lot easier for the users because A, you get autofill, and B, you get a lot more security. So it makes your life better online. Now, phishing and social engineering, this affects all classes of wallets. And unfortunately, this is the absolute hardest to protect your users from. Fake investment scams, right? Somebody contacts you, somebody sees that you're into cryptocurrency and contacts you out of the blue on LinkedIn or Instagram. I'm, Jane Forex trader, right? If you invest $1,000 with me, I'll make you $9,000 in a week. These are real and they really do get people. It's the fake giveaway scams, right? Send me cryptocurrency and I'll double it and send it back to you. The ledger data breach related scams, extortion, fake software updates, like ledger users being targeted specifically because of the Shopify leak. It's kind of easy as technical people with a lot of know-how to say, well, social engineering, if you send your Bitcoin off to some stranger saying that they can make you $1,000, that's your own fault. That's kind of, idiotic of you. And I think it's really important to have a lot more empathy for people that are victims of these scams. The reality is social engineers are professional predators. They prey on our humanity, they prey on our greed and our weakness. And people that have fallen for these scams come from all walks of life with all levels of know-how. And so, don't just assume that if your users are smart enough to interact with cryptocurrency, that they're also smart enough to not get scammed by one of these supposedly obvious issues, right? This is something that people make their livings stealing from other people using these techniques. And, especially as penetration testers and security professionals, I think you all know how powerful social engineering is. And so the only way to prevent social engineering being a route for stealing from people is education. We have to really train our users on social engineering. I think that social engineering related information should be built into cryptocurrency applications. So, with applications that interact with addresses, maybe, do things like search for known database of scam addresses and give your user a little warning. Right. Of course, we don't want to be in the cryptocurrency space in the business of censoring transactions. People should always be allowed to send money to any address they want to anywhere in the world. That is a critical core component of cryptocurrencies and their censorship resistance and their global nature. But, presenting a little warning to your users about social engineering threats, maybe when they load up their wallet, and then they can dismiss that. Those things can't hurt, right? It's important for people to know about these attacks. So let's end with the good stuff. Bullet points that you can give to your users. Encourage hardware wallets for high value accounts. I think this has kind of become the gold standard in the industry. Make sure that if you are storing your life savings, you're using a dedicated offline hardware device. Encourage mobile wallets for spending money. So if you have spending money amounts, you want to keep your pocket change in there, be able to send, to introduce new people to crypto, pay your phone bill, buy a book, buy electronics gear online. Again, things I like to do with my crypto, right? Use mobile wallets because they're generally a little more locked down and present less attack vectors than maybe a desktop wallet would. They're not foolproof, which is why I wouldn't recommend keeping your life savings on one, but they're pretty useful for day-to-day introduction to crypto and spending money. Encourage and require strong passphrases, length over complexity for wallets and exchanges. Don't enforce a password policy for your web wallet or your exchange that means the user is going to end up with a short and less memorable password with a bunch of numbers and symbols in it, right? Encourage longer passphrases instead. Encourage a minimum of 12 or 14 or even 16 characters. I like to go with 20. I think 20 is even an ideal starting point for password security. This encourages people to use password managers. Encourage or require strong app or hardware-based two-factor authentication. Again, use modern standards like TOTP for auth apps, or use the U2F or FIDO for hardware keys like YubiKey. I know it's maybe a little bit more engineering work, but yeah, I personally, I always love when I go to a website and they allow me to use a YubiKey as two-factor auth. That makes me feel more comfortable that they are taking my security seriously and they are enabling me to take my own security seriously. Train your users on social engineering. Again, this is no easy task, but in some creative way, I think it's important to make your clients and your users of your applications that you build aware of social engineering techniques that are common and pervasive in the crypto space. Make sure they have a heads up about the type of scams that are out there, and it can prevent them from being stolen from by their own mistake. The security landscape is ever evolving. So of course, I'm a software engineer and a tech educator by trade, not necessarily like a security pro like many of you in the audience. So this is not meant to be a comprehensive list or extreme security expertise. This is about, some of the broad classes of security topics, threats, and best security practices that are currently being worked on in the industry. Always be open to new information and feedback. I like to learn something new every day. And, I think that it's important for us as security and software and education and marketing or whatever you're doing in the cryptocurrency space to always be learning, because this is a young and very rapidly growing space. With great power, being your own bank, comes a great responsibility to take your security and the security of your users seriously. So overall, train your users to think about security first. Whatever you're doing with your app, your testing, your promotion of a particular project, always throw in a note about security. A simple note, simple bits and pieces about security best practices can save your users from headache and harm. And develop your software with security first mindset. It is fun when you engineer software, and especially if you're making things that are just educational, to go fast and break things. But especially if you're developing production software that is really meant for people to use with serious money, always have security in the forefront of your mind. Security is critical in this space where leaking a private key could mean somebody loses their life savings. So take it seriously. Make sure your users take it seriously. And it's always great to learn something new about this. So thank you all very, very much for having me today. And I'm going to open up the YouTube stream here and mute it so I don't get echo, and I can take some questions if we have a couple minutes, of course. Any questions in the chat?
Hey, Josh.
Yes.
Okay, so I think there are no questions. There's a comment from Nathan. He's saying, love your work. I'll definitely be looking through your resources on your website and sharing it wherever I can. Thanks again for the presentation.
Yeah, thank you all so much for having me. My main website is chaintuts.com. I have a contact form on there. All my social media is on there, and I'm mainly on Twitter at ChainTuts. So please feel free to reach out if you have any questions. My slides and this video will be on the website and my YouTube channel as well. Thanks again, team, for having me. This was great.
Thanks, Josh. Same here for us, and thank you for sharing your knowledge with us. It was a wonderful pleasure for us to host you in our Unchained Blockchain Security Conference. And yep, that's all for the session. And we'll see you soon in the next event.
Take care, everyone. Enjoy the break.
Yep. See ya. Bye bye, Josh.